the morning session will be followed then by the explanation of the research and innovation activities, where we don't have yet the solutions ready for the market, but that we are building up in Europe's Rail innovation program. So in particular, we will be looking to the 7 flagship area and exploratory research activities, and these will be presented by the program manager of Europe's Rail. Following that, you will have also a state of play and the first results from the system pillar. And important, we are talking about an integrated program in Europe's Rail. So we needed to take care of the synergies that exist, not only as it was shown yesterday across programs of the European Union or across agencies and institutions or member states activities, but especially we need to get it right inside the Europe's Rail program. So the synergies among the flagship projects and the synergies with the system pillar. And then we will end our morning session with something that is extremely important. I have already mentioned it yesterday. We can do the best innovation and research in the world, but if this is not properly communicated and disseminated, we are invisible. So we are putting a lot of attention on it, a lot of pressure on our teams, but also a lot of pressure on you, because you are the one that are in charge of the projects, and you have also dedicated resources for communication and dissemination activities that we would like to do it in a coordinated manner, so that they don't appear like small and uncoordinated projects and dissemination activities, but really as an entire program with having a bigger effect. So having said this, well, I welcome back again all the audience. As housekeeping, as yesterday, we will be registering this session, recording this session, and all the questions, we will do it like yesterday, but those of you that were not there yesterday, if you have questions, write them in the chat. At the end of each session, we will look at the questions in the chat and reply to them already, so what you have. For those of you who are here around the table, and for everybody to know why there are people around the table, it's the governing board that we had yesterday. You can simply raise your hand and you will be given the floor to ask the question. So I think I have said everything for kickstarting the activities. So let me introduce the next session, which is about the success story from the shift to rail innovation. And we're starting with the connected driver advisory system, with a presentation from both Philippe Novak and Bernd Foster. So the floor is yours. Normally you are online.
Thanks a lot, Giorgio. I can take over. So hello and welcome everyone to the presentation about the connected driver advisory systems developed within the IP5 Freight family. Normally, as announced to Giorgio, you would expect now Philip Novak, a colleague of mine, to take this presentation, but he is in a train running late, and so therefore I need to jump in. Together with me, there's Bernd Foster from Knorr-Bremse, which was the industry partner within this development. And also Philip is with us, so if there are more technical questions at the end, he can also then jump in and support us with more details from the operator's perspective. Also, it needs to be highlighted, I think George said it, it was a little bit cherry picking. We had a lot of really successful and good innovations within the IP5 family. Some to highlight here, our ATO freight demonstrator, distributed power systems, condition-based maintenance. We have developed 2 wagons, innovative freight wagons within the IP5 program. And now this morning we have just 2 highlights, the connected driver advisory systems and the intelligent video gates, presented then afterwards from Besat. Next slide, please. Can I jump or is it? Perfect. So our presentation today is split into three parts, and we will start with a little bit of basic information. What was the objective here behind this development, and where was it exactly developed, with which partners, etc. Then we are getting more into the technical details. So what exactly was developed here within this driver advisory system topic, and also what tests we did with the system within the program. At the end, we will highlight some results from this, so how we came then from the research and development part to the market uptake, and also what benefits we have here on a technical perspective, but also from a society perspective for the overall European Union. Next slide, please. Starting with the overall management summary here for this topic. So the objective here was to define requirements for functionality on a digital advisory systems within the freight context. Based on this development or these requirements, we developed prototypes which were then tested under real conditions in overall 100 locomotives. The partners within this innovation was we were the operators, DB Cargo, then the infrastructure manager, our partners from Sweden, Trafikverket, and then from the industry side, we had here Bombardier, Hitachi, and Knorr-Bremse. One thing that also I think can be highlighted, because it was a challenge for all the projects on this time, that besides COVID, everything could be finished on time. And this was really a highlight here, and congratulations to all the people involved there to make this happen on time here with the test and development. If you want to find out more technical details, we have here, it was developed under Freightwell 2, Work Package 4. There were 4 different deliverables, and I think all of you know where you could find them if there are more interests from your side. Next slide, please. Yes, as a starting point, as you can see here on the left side of the slide, this is our current leader technology that we have equipped at this time with overall 650 locomotives at DB Cargo. And this is just a small screen which provides several information for the local drivers. And on the basis of this existing system, we have developed a functionality called far side and rear view, so that the train driver receives information what happens in the back and in the front of his track, and then gets here recommendations. It's just recommendations to adapt their speed, their braking, etc. This is currently equipped at 4 different loco types, and we test this within the IP5 work in overall 100 different locomotives. And now I will hand over to Bernd Feusner, if he's, oh yes, he's here, with more technical parts, and then I will summarize everything at the end. Bernd, please.
Thank you, Patrick. Yeah, so hello all from my side. So here, as Patrick said, far side review, as the name already said, is more or less we show the driver, the occupied blocks and the free blocks ahead of the train, of their own train, and in the back of the train. And we indicate that by colored bars. So that means, as usual in rails, 3 sections ahead and so on are in so-called blocks divided. And each block represents one bar on the display, so that the driver can see whether a slower vehicle is ahead of him, and it's make no sense to speed up. Or we have also seen a psychological effect from this far-side review feature when we get the messages from landside to the locos that in previous times for Polido, for the driver advisory systems, we got the feedback from several drivers that they fear that they get an angry call from a dispatcher why he's driving so slow as recommended from our system. And this fear we can take more or less aside when the driver sees that nobody is in back of his train and nobody is pushing, and he's also not an obstacle on the route. So then he can also follow the advice, without this fear. So the next slide, please. Thanks to DB Cargo, they also made a huge campaign to gather the feedback of the drivers for this feature. And the awesome result was really that, as you can see, more than 3/3 of the drivers welcome this new feature and consider it as really helpful. And of course, additionally, we collected also feedback, what could be improved or what is really a benefit for them. Next slide, please. So, and we think that this good result is also based on our agile approach. So we developed it in several steps in an iterative approach. You see on the left side, for instance, lower the blue bars or blue and orange bars. This is the display of the far-side review, and we started only with the bars. Then 1 month later, we added also information which kind of train is ahead or in the back, and what is the average speed of the train on the planned way for their own train. And the right hand is then the final implementation. So I guess this iterative approach was very welcome to the drivers. So next slide, please. Here you can see the display of the advisory system. So on the yellow cap is a symbol of the head of the train. And above the window is the topology of the train ahead. And down is the advice area where the advised speed is given. And as you can imagine, these bars, which are grayed out currently because not displayed, this is the far-side review feature. And if you can start perhaps the video, the small video, you get an impression about it. Yeah, so here is the color. So 3 bars ahead are free. And then there's an obstacle. GV means freight rail, or SON is a special train, 123 kilometers average speed. So it and in the back is a passenger train with 160 kilometers per hour. So this is the main feature we implemented here for shift to rail. Then thanks back and back to Patrick.
Thanks, Bernd. So please, next slide. So after this development and testing, we try to measure the impact of the solution with 2 different approaches. So the first one is what we wanted to achieve to reduce the number of unwanted operational stops. This is always not good within our operation. It leads to material wear out, it costs time, etc. Here we had at the end a strong indication that we could reduce this number. Of course, it depends strongly where the train is driving, etc. But we can say here at the end we have a strong indication to reduce these numbers of stops due to this development. And also what is really important are the energy savings. And here we can provide clear numbers. And I think today it's even more important to have energy savings nowadays. And here we did a kind of complex comparison, but we can say now that in comparison to the initially DAS leader system, and now with the functionality F&R, we can say that 2.5% we are better with this solution. We can save this energy. So overall, we have here clear outcome of the solution, that we can reduce the number of operational stops and also can save energy within every train ride. Next slide, please. Yeah, taking now a look, so what was done within the research and development part from Freight 2 and how we get then to the industrialization, rollout, market uptake within DB Cargo. So the focus of the work with Freight 2 was, of course, on developing a prototype for demonstration purposes. So we want to have a short and incremental development that we can see, okay, how big are the benefits? And as we saw on the last slide, oh yes, there are good benefits. So let's see that we can get the solution on as much locomotives as possible and as fast as possible to really have these benefits as an operator. So the development was here, like we call it the green banana, so fast testing, etc. And then afterwards, we said as DB Cargo, okay, we want to continue this work, and we got into a customer supplier relationship together with Knorr-Bremse, and then we had the last fine-tuning of the solution, make it more robust, more maintainable. Also, we need more documentations and training efforts for the train drivers. But now overall, we are really using this solution on an everyday basis and could therefore have really benefits for DB Cargo with this work starting in Shift2Rail. Next slide, please. So now we are on the last slide to summarize everything. What is really now the benefit with this development from Freight 2 with the CDAS? Of course, we can say we have here more climate protection due to the energy savings, so additional energy savings up to 2.5%. We can save here, energy. And we can also reduce the braking, also the noise level, so reducing the material wear out due to the solution. We can also indicate that we have more capacity due to this development, so that we have less operational stops, which could then lead to jams within the network. We can also say, due to the solution, we have more capacity on our network. And last, of course, if our quality is better, if we are more punctuality, we have a better punctuality due to the solutions. Also, it's more, or it's a higher quality for our customers, and hopefully, therefore, we can also increase the modal shift. To summarize everything, this is one of many examples, so how really things can grow within here the Shift2Rail work. So we had here a good platform to working together with several partners, industry partners, that we could test something really fast with a short development timeline, and then learn something about the solution, see, okay, yes, we have here benefits, and then came afterwards to a customer supplier relationship to really roll it out within our organization. So then, thanks a lot. This was the first solution for today. Now I can take over to another solution out of the IP5 Freight family, and I would like to take over now to Besart Kortenyard, who will present something about our development for the intelligent video gates.
Thank you, Patrick. Thank you. Good morning to you all. I hope you can hear me, and maybe I can also get the slide there. Yes, thank you. I'm a researcher at KTH, Royal Institute of Technology, and I have been assisting Swedish Transport Administration, Trafikverket, with leading this work. So I have the pleasure of presenting some of the results there. Trafikverket has been represented under the leadership of Mr. Jan Bergstrand and Mats Åkerfeldt. And this has been very much a collaborative, successful work here together with DB Cargo, Hitachi Rail from Italy, and Indra from Spain. And also RISE, Research Institute of Technology, in Sweden. Sorry. Okay, next slide, please. Maybe I can share. Okay, thank you. And so the concept, which this image tries to illustrate a little bit holistically, it consists of gates that has video cameras and RFID readers attached to them. So the videos are then used for image analysis and through machine learning techniques trying to identify what we deemed as useful information. So this could be wagon code, sequence of those, loading unit codes and sequence in the train of those. So different numbers and codes. And dangerous goods, the placards was also very much a focus, trying to identify those, and as well as damage detection. So you can say damage detection was perhaps one of the first use cases as damage detection is essential at the handover points. So when you have this kind of information optimized and digitalized, obviously operations can be improved and you can share this data in a much better way. Yes, we can proceed. So the results we're presenting here is just a minor part, you can say, of shift to rail IP5. But we have been working with this concept for a couple of years now within the framework of Freight Hub, Work Package 4. We developed the concept, you could say, and showcased it on a model train at Innotron 2018. Within Freight Rail 3, we went a step further and actually had physical installation of these gates, one in close to Port of Gothenburg in Sweden, and also we had the gate in Nuremberg Yard included in the project. Yes, next slide. So the idea about image processing is then essential that through the captured images, you can identify these type of codes and dangerous goods placards, which I mentioned. And you complement this with the information captured by the RFID tag and the RFID reader. So Indra, who was responsible for the image processing here in the project, they developed a deep learning model for being able to identify codes and dangerous good placards. The damage detection, the use case we identified or were able to work on was graffiti. So this is the first type of damage, you could say, that we identified and detected. Next slide, please. So as mentioned, the data sharing part is also very much essential part of the project. So the captured data in the physical gate were then transmitted to a FTP server and then further transmitted to the deep learning models of Indra for identifying the things that I mentioned before and the image processing. We also use the data platform for sharing this data, Deployed, which RISE were responsible for. And we created a user interface for data consumers, end consumers, you can say. So this data sharing part was then not done on edge, but like this on the spot where the physical gate is positioned. So we think that this is something we can improve further. Next slide, please. So the use cases that we identify and we worked on as a part of a data exploitation of the data captured by these gates, you can see them here in this table. First one is connected to the previous slide, that is the data sharing to the customers, to the end customers. So you can have precise timestamp information about the rolling stock and trains, and if there are any estimated deviations. And as I mentioned, we had this user interface developed within that use case. Moving on, we also thought that planning, especially transshipment planning at intermodal terminals, could be improved by being able to automatically and digitalized way acting to deviations, for instance, in the sequence of the train. So in turn, that would also then obviously lead to energy savings at the terminal. The results, the detection rates we reached within Freight Rail 3 were that we identified 80% of the wagons and 85% of the ILUs at the gate in Gothenburg. So there are potential for improvements there. I don't have the time to go into the details there, but we think that it's possible to reach 95% above for those detection rates. For the damage detection, the graffiti then detector, it was able to detect 98% of the damaged wagons, so that was quite high. And the dangerous goods placards were only 70%. And we had ideas that other type of cameras could improve those results. We had a use case trying to optimize scheduling from a traffic management system towards this dangerous goods placards that are detected in order to minimize exposure risk in case of rescheduling. So that was a use case that Hitachi were responsible for. And also we had several use cases for IVG at yards, mainly related to maintenance ordering of rolling stock. Next slide, please. So to summarize, the impact of this innovation has been to reduce administrative burdens, have correct customer information, timestamp information, in order to improve terminal efficiency and yard maintenance developments, you can say. So better documentation, and also to have an additional view on the wagon from above. So that would increase safety for having less workers at the tracks as well. So having this kind of real-time data, as mentioned before, you can plan activities better in advance and act to deviations. And having a possibility to share this data across Europe and across locations. So we had, as a result of this project, we made a dissemination video. I'm not sure if it's possible to press that and if it works. No, it didn't. But yeah. So that's, we can jump that. But you had the link over there. If possible, you can also look at that. So to summarize, we will continue our work within the Europe's Rail, flagship project 5, and the work package standardized European railway checkpoints at operational stops. So we will take this concept a step further, also including border stops now, and trying to propose a standardized approach for, since this concept is then further elaborated and installed across Europe. Okay, with that, thank you for your attention.
Thank you very much, Behzad. Thank you also to Patrick and Bernd. So without wasting further time, wasting in the between brackets, or at least from my side, I will immediately give the floor to Benoît Bienfait, that is presenting the automated train operation results. There are also questions in the chat. Please don't hesitate to ask them, and the speakers, you can already reply them directly in the chat also. Like that, we gain time. And Benoît and further speakers, please try to stick in the 10 minutes presentation. The previous one did a great job, but a couple of minutes more. So, Benoît, the floor is yours.
Okay, good morning, everybody. Can you, yeah, you can go to the next slide. So my name is Benoît Bienfait, working for Alstom since a very long time, and leading the TD2.2 work package in Shift to Rail ATO up to J4 specification. You can go to the next slide, please. Next. Yes. So I will focus on, I will be rapidly, so you will see the slide after, but 5 topics. The first one, just a summary about the grid automations and incremental way of work and architecture we have developed. Then a focus on GOE2, big achievement, because we, as you know, perhaps, we have specified the different subsets which are now part of the TSI 2023 to manage GOE2. Then some slides on the pilot test for GOE2, and finally what we did this month, by the way, the pilot test in A2A in GOE4, which is also a big success today. Next slide, please. Yes, voila. Next, I will go next. You can click one. Next. Stop. Oh, one back, please. One back. Voila. So this is just a slide to summarize the different grid automation and identifying that we are working since a very long time on the way for interoperability and interchangeability. This is the key words for what we did since 25 years. Grid automation 0, it is the driver which is driving the train alone, the boss after God. Then GOE1, we have the protection by ETCS, by ETP. And so we have worked a lot all together with the companies to specify standard ATP system. GOE2, first achievement in shift to rail for the TSI 2023, we have specified the standard specification for it up to GOE2. The driver is still in the cab, but pushing the push button and the train is running automatically until the next stopping point. GOE3 and GOE4, it is the last work we have done in shift to rail. We have delivered standard specification, system program specification with an architecture which is quite incremental. We have worked as much as we could in parallel with Sfera, joint meeting with Sfera, joint work with Connecta, with Okora, and also RCA. And now the next step will be Europe's rail, continuing to work until we have large-scale demonstration. You can go to the next slide, please. Yes, this is the incremental approach. I will not detail the architecture, of course, but you have to know that we have defined logical blocks which are fully interchangeable with standard interfaces, permitting to implement for the customers the different grid automation according to their need, and could be an incremental approach. GOE1 is the first level, where you have only the train protection on the left. The building block on the bottom are on board, on the top are track side. And so the first grid automation is one with only ATP, with a localization based on satellite and a repository which is managing the track train communication. Next slide, please. The second step is the DAS application. We spoke about that just before. We have worked a lot with Sfera colleagues, another European project working on DAS applications, but on an interoperable point of view. And so we have to work with them to agree on the architecture you can see here. Once more, the logic blocks below are on board. The repository is managing the track train communication sessions with the trackside servers. We have still the localization, and now we have the DAS functions supporting the different standard interfaces. C22 to recover the what you call the journey profiles and segment profile, and also optional interfaces like the interface with the ETCS 130, which is existing today in the TSI, and 139 with the train to collect information coming from the train, not to drive the train because we are a DAS. The next step, next slide, is GOE2, complied with the TSI 2023, functionally speaking, with the repository collecting the journey profiles with the timetable and so on, and the segment profiles coming from digital map with the track plan data. And then the automatic driving module driving the train. You see the interface below, 139 in the TSI, permitting to drive the train automatically. 130 interface with the ATP to avoid that the ATO, like the DAS, displays something which is not consistent with ATP. Next slide, please. Then we are going to the GOE3-4. We just add 2 new modules, the perception module, looking for the obstacles on the track, and the APM, replacing the brain of the drivers, reacting in case of obstacles or even coming from the TCMS, the rolling stock, which is below. And the APM is giving information to the ATP to change the movement authority according to the obstacle detector. So clearly an incremental approach. And the last slide is indicating the last step where it's possible in the architecture to use the signal detection cameras, detecting the aspect of the signals, and these aspects are translated by the signal converter in ETCS level 1 packets, meaning that you can operate a train in an area which is trackside not yet fit for ETCS. And ETCS on board protect the train according to the signal aspects. Next slide, please. Then this is the design criteria. I will not spend time. You can read it carefully. The design criteria to build this architecture. And on the right, you can see the different logical blocks I mentioned with the incremental approach supporting the different gate automation. You can read it carefully later. Next slide, please. Have a look now on the GOE2. Voilà. This is the timescale of GOE2 leading to the TSI, which is a very good and impressive success of this team, but started already in 2012. We started to work with the suppliers and the users to harmonize the users' vision on that. In 2012, the first version of the document was delivered to ERA in 2014. Approval from ERA, first one in March 2018. We have developed inside shift-to-rail prototypes, and we have made tests in 2019 in factory, mixing the solutions of the different suppliers. Interchangeability is the key word. And we had also performed pilot tests on site in 2 pilot tests you will see later. And finally, the TSI has been frozen for RTU in March 2022. Next slide, please. Yeah, the findings, of course, we have taken into account. Next, yeah, this is just a focus on the different subsets. You can go. You can select the next one. Next one. This is just a list of the subsets which are in part of the TSI. We can read it carefully later on. We don't have to spend time of that. It is just all the subsets which are now part of the TSI. What about the pilot tests? First, you can click next. Voilà. First, we made some pilot tests on reference test benches, 2 reference test benches developed with standard adapters. You can see ATO on board and ATO trackside connected to the testing platform. And so we specified that jointly with Siemens. There was 1 reference test bench in Germany and another in Belgium. And we have tested several configurations. Next slide, please. I have no time to detail. These are configurations, 2 configurations tested on the Alstom platform and 2 on the Siemens platform. You can read it carefully later. These slides summarize what we did and on which configuration. Next slide, please. This is the pilot site on test. 2 tests, important tests. First in UK with a very old train, class 313, with an Alstom ETCS. We have tested the onboard of Alstom and AZD, plug and play with interface with ETCS and the train. The trackside was delivered by Siemens and Thales. And we have tested with the communication using GSMR GPRS standard interface. And the second one was on a cargo train in Switzerland, Trax train, which is from a Bombardier train, ETCS from Siemens. We have tested 4 ATO on board, Alstom, Hitachi, AZD, and Siemens, with SBB for the trackside. And we test their public network. So standard interface, as mentioned in the TSI, but using the public network as it is foreseen today. So plug and play solutions, we have demonstrated that also in Switzerland. Next slide, please. I'll focus now on GOE4. Once more in GOE4, we have realized after the architecture I've presented to you, some reference test bench, 2 reference test benches once more, one in Italy made by Hitachi and another by Alstom. You can see here the new modules, the perception APM repository that you have seen rapidly in the architecture. And so these references bench has developed standard adapters to connect, to plug and play these modules, new modules to be tested in factory. Next slide, please. Then this is the pilot test on site, successful pilot test made in November and December of this year. You can see the team here with different configurations on board. Here you can see sensors coming from Hitachi and AZD, also the modules inside from Alstom. We have tested transition between GOE2 and GOE4, so driverless, unattended. We have tested the stopping in front of an obstacle and automatic restart, removing the obstacle and passing a non-protected level crossing. Of course, it is not impressive because GOE4 is well known. What is very impressive is the interchangeability of the solution. We mixed the different products. Next slide. We can go to the conclusions. For Joey 2 first, it's no reality, definitely. We have no mature solution. Full interoperability has been demonstrated. Pilot tests have demonstrated the deployment of Joey 2 on existing trains. Because we have used existing trains, we have just developed some functional adapter permitting to provide the standard interface with the train to the different ATOs, and the adapter was managing the specificities of the train. And the interoperable specifications are now clearly in the law in the TSI 2023. And for the Joey 4, we have achieved a standard architecture agreed with Sfera colleagues for CDAS connections. We have performed pilot tests in factory and on site, and the demonstrator findings have been recorded, of course, not implemented in the next version, because this will be the duty of the next program, which is Europe's Rail, to continue and to consider the findings that we have recorded in the different pilot tests in factory and on site. You can go to the next one. What is very important, we can conclude saying that the ATO specification, too rapid, are prepared in the frame of Shift2Rail, XORail 1 and 2, and no projects are used for product development by several suppliers and also applied in current and future revenue service. So probably a lot of you follow already some commercial implementation of the Joey 2 standard specification. Voilà. Thank you for your attention.
Thank you very much, Benoit. So it's also very much important that you say that Joey 2 indeed are already used in a future commercial contracts. So if we move on, we have Zbigniew that will present us the work being done in the context of the Shift2Rail program on ticket vending machine.
Yes,
So are you
I'm
here?
here.
Yes,
Yeah.
perfect.
Good morning, everybody. I want to present the commercialization of ticket vending machine, which is a result of one of our projects in which we was involved. The project name Extensive is the project which we have done in the IP4 Innovative Program 4, but it was the continuation of few previous project which was done in IP4, like attractive, connected, cohesive, and massive. And of course, the assumption was to have a synergy with IP3 project. One of them was the Intertempo project when the PKP was involved too. And we wanted to use some results from that project. Especially, I will talk about work package 10 when we plan to use the infrastructure station to improve the passenger travel from door to door. So if you can make okay, that's next slide. So in extensive project in work package 10, we wanted to use some results from Intertempo project. One of them was a technical wall when that should be installed TVM. The first idea was to do the demonstration of extensive project in the place when the demonstration of Intertempo project was planned in Jurata station in Poland. But unfortunately, the rebuilding of station in Jurata was not possible because the COVID and because the crisis which was after the starting the war in the Ukraine. So we had to find another solution to use in the extensive project. So the parallelly we started in PKP preparing the project named Universal Ticket Vending Machine, which assumption was to engage and to sell tickets of all passenger carriers in Poland. So we decided to use this machine in extensive project as a part of demonstration. And because the Jurata station wasn't present, we had to move the demonstration place to the Pomiechówek station. It's the small station similar to Jurata station in the central Poland, not far from Warsaw. So we had possibility to do the demonstration. Next slide, please. Because of this new ticket vending machine had to be improved to be used for extensive projects, we have to do some work in software. We have to prepare in the user interface for the TVM, and to connect with the system selling tickets, which we use for selling the common ticket. The common ticket is the one of the idea in Poland, which allows to sell one ticket for few different passenger carriers. So the new in this kind of ticket is the digressive tariff. How longer you are traveling, the lower is price for 1 kilometer of your journey. So this idea was to use the common ticket, TVM, and some other elements which we was developing in an extensive project to use in the TVM. The second part which we used and which we have been developed in the extensive was the part of kind of database named IRIS. When we try to improve some information about delays, about changes in the road, so we used this information in a ticket selling system, and of course it affects on the TVM during the process of selling ticket. Next slide, please. Okay, why we try to, because you can say TVM is not, it's nothing new, it's nothing innovative. Of course, it's true, but why we was thinking about this kind of project? In Poland, we have a situation when passenger carriers and some operators install their own ticket vending machines. All of them have a different process of selling ticket, the different interfaces. Passengers can't use one type of interface, one way to buy a ticket, to choose the route and to buy a ticket. So we tried to solution for this. Of course, the second reason is that the costs of standard cash office at the railway station are higher, especially last year. So we had to find a solution to give the passenger alternative way of getting ticket at the railway station. So the ticket vending machine was the good alternative for the closing of the cash office at the railway station. Okay, and the main assumptions of this project, this universal ticket machine, was to allow to sell tickets of all passenger carriers. Of course, we wanted to be transparent. We wanted to treat each carriers in the same way, allow them to give them the same access rules to access to the network of the TVM installed on our railway station. We don't want to favor any carrier, even the carriers from our capital group. So that's the most important thing, that every of them is treated in the same way. And of course, we try to do the process of selling tickets much easier than it is now, and much simpler than as much simpler as possible, because we want to convince passenger to use the ticket vending machine, and maybe after that they will move to the mobile canals of selling the tickets. So that's we think that TVM is the next step after standard cash office, between the mobile canal and the standard tickets. And it's of course the idea how the passengers could get a paper ticket, because some of them still want to have a paper ticket here. Next slide, please. And of course, the tests of the TVM took place at 25 of August this year. And of course, the tests passed without any problems. We could choose a road between two places. We simulate payment and we print the ticket. Of course, using in the ticket we used the standard of UIC, QR code standard for UIC, which we will use in the ticket selling in our TVM later. So is the one of the effect previous project named Massive in the IP4, and we decide to use such a QR code in the ticket which we will sell in TVM, in universal TVM. Next slide, please. The next step for us was to improve the interface and improve the system for selling ticket and to show the prototype on the Krakow fair in Gdańsk. The Krakow fair was between 18 and 21 of September 23, and our stand, in PKT stand, as Krakow, we showed the machine, to be vending machine, and we present a full ticket selling process, but of course, related to the test environments, not real, but it was full ticket selling process. We of course collected the comments from users. We propose them to take part in survey, and after the trial we get some information how to improve, what to change in the interface for the TVM. Next slide, please. And now we are preparing to start the pilot in the real station. We, together with our carriers, passenger carriers, we choose some railway station, a different type, not only the biggest one. We want to check during the pilot few types of the railway stations, small, bigger, and any other types of the railway station. So at which of them the TVM will work the best, and when the passengers' needs are shows that the TVM is needed. So we plan to start the pilot in the first part of 2024, and the pilot is planned for 6 months. After 6 months, we want to decide to do the commercial implementation and to improve the number of TVMs to install it at the other stations. So in January 2025, we will decide to go or no go to the full implementation. So from my side is everything. If you have any question, I can answer.
Thank you very much, Zbigniew. And I think also this shows that we're not doing only, let's say, paperwork, but we can see also technical results out of real hardware. And this it's perfect to bridge to the next presentation, because it's also a lot about hardware. We're talking about use of silicon carbide in traction systems. And we have Laurent Nicot connected as usual. If you have any questions, please write it in the chat and we will try to reply to them. Thank you very much. Laurent?
Good morning. Right, I think we could move to the next slide. Right, so I'm going to present the results of several projects of Shift2Rail working on the silicon carbide technology. We tested several prototypes because several train manufacturers developed this technology for different applications. We had Siemens on tramway, CAF on metro, and Alstom on regional trains. The idea was to demonstrate that this new power semiconductor silicon carbide technology is valuable for traction system, is operational, and is giving the expected nominal performances. So the different KPIs confirmed during the demonstration was on life cycle cost, reliability of the traction system. We had some gains on weight, volume, and noise of the traction system. Next slide. All right, so this first slide is to present what Alstom developed and demonstrated, and the following slide will present what our colleagues from other companies done. So you can see, as Giorgio said, that we develop hardware. So we developed several components of the traction system, trying to optimize the global traction system, starting from the traction transformer, including the traction case. You can see the picture of the traction case here, mounted on the roof of 4 cars, I think 4 or 5 cars on regional trains. We also developed dedicated motors and gearbox to optimize as much as possible the global results of the whole system. So very briefly speaking, we made a lot of tests to validate the technology. So that was, for example, air leak on the roof, to have a natural cooling of the transformer. We characterize also the electrical noise of the system. We tested the vibration. We tested that the system is reacting properly to vibration test, shock and vibration. We made brake performances measurement. We validated the thermal cooling of the system. We also checked that the electromagnetic compatibility norms was respected. And of course, we quantify the energy efficiency. So we have described all of these results in dedicated report. So the system was tested on a regional train on a test ring in Czech Republic, in Berlin. And we realized these tests between the end of 21 and the beginning of 22. Next slide, please. So the second demonstration, as said, was done by Siemens. And Siemens developed a transformer and traction case for tramway application. So they made this development to optimize the system for an AC traction system. They quantified also the energy consumption, checked that the generated harmonics from the power semiconductor was acceptable, and gave also a complete test report on many aspects, including also acoustic noise, where we have some gains. So the test was done on a tramway in a commercial service in Germany, in south of Germany, and Siemens also released a press release to inform, I would say, the community about this successful test done on 2021. Next slide, please. Finally, a third manufacturer developed also the technology for a metro train that you have on the screen. The traction system is mounted under the floor of the metro, and CAF made also more or less the same validation as the other one, including EMC behavior, energy efficiency gain, verify the cooling of the system, and reported all of that in a dedicated report with quantified figures. So the test is it was done for long duration during 1 year between 2021 and 2023, so it's 2 years, and finished recently at the beginning of this year. Next slide, please. So finally, we also reported the chart that you can see here. It's a little bit complicated chart, but simply speaking, we quantified reliability, the contribution to the train capacity through the weight reduction or the volume reduction of the traction equipment, the noise reduction, which is also globally important and especially for urban vehicles. And in parallel, of course, we also try to see if there is a viable economical model to sell the technology. So briefly speaking, you can see very impressive energy savings here between 5 and 13%, depending on the application, depending also of the level of optimization. Maintenance is also reduced due to simplified cooling system. Reliability is higher than the previous silicon technology. Weight and volume saving are also pretty impressive because the technology allow much more compact equipments. And noise is also pretty impressive, especially on suburban application, as you can see here. So the benefit to develop this kind of technology in a partnership, first of all, of course, is getting public funding, reducing our financial risk, because at the beginning of this work, let's say 6-7 years ago, it was not sure that first of all the technology would be able to be mastered, and there were also risk on the life cycle cost and the capability to sell the technology in comparison with the gain the technology is proposing. And the second interest of to develop technologies in the different project of Shift to Rail is that we had in the same project both the train manufacturers and the 2 major operators with DB and SNCF, and that was the occasion to test in real time the interest also of the technology from the operator's view, and get also the operators' constraints in operation and in maintenance, just to secure the fact that the technology will also be will also give benefit to operators. So where we are today, that's pretty simple. The silicon carbide technology is used now in series commercial products. It is used for auxiliary converters and sold already on commercial project. It is used now more and more on DC-DC converter for battery trains called BMUs, because it brings different technical and economical advantages, and it also offered or sold on traction system, complete system by European manufacturers. The cost actually is a little bit higher than the classical technology, and then depending on the price of energy in different countries for different customers, depending on their own cost of maintenance, you can find an interesting business model in a certain case. Next slide, please. Right, so in conclusion, we can say clearly that the 3 demonstration was completely successful from the different manufacturers. It took 8 years, so it was a bit long because it's a very important changement in the traction system approach. And it was also important to stay in the race against the Japanese or Chinese competitor, because you know that Asia is also very, very active on this kind of technology. Just for your information, so the Japanese are selling this technology on Shinkansen since 2020, and the Chinese CRSC are also selling this technology on metros and tramways since 2021. And especially there are several cities in China equipped with silicon carbide traction system. Okay. So maybe I will not take too much time because I think we have one more presentation before the end of the session. But now the technology is mature, it is offered and sold on markets. Lesson learned. So globally, we mastered the technology, as said before. So there were some challenges, but all of them have been tackled properly. The commercial takeoff started in Europe. I believe that it is a deep trend. So I don't believe that that will be only a local phenomena. I think that will be generalized in the coming years, and especially because of the scarcity of the clean energy and the cost of energy. And what was also important is that this type of project in this European context allow to accelerate the innovation process and standardization and help European industry to compete with non-European competitors. I think that's it for this presentation.
Thank you very much, Laurent. I think also these show good results that are now put on the market. It also give us the lessons learned to never stop to innovate, and it will be better next time to be ahead of the competition. So let's continue to invest together and build up on those successful results. Thanks a lot. And I give the floor to the last presenter of these sessions on the Shift to Rail. Marco Bonato could not be with us today, and we have instead, I think, Giulia Vignola, correct, that
Yes.
will do a presentation on the intelligent asset management.
Yes. Good morning to everybody. Okay, thanks. Next slide, please. Okay, so I'm going to present the results of Into Smart 2 project, that is a Shift to Rail project related to asset smart maintenance. Into Smart 2 brought on the work done in the previous project Into Rail and Into Smart, and it was supported by various open calls. Such as Stream, Momit, Into Dreams, Daydreams, and Assets for Rail. Thanks to all these projects, Shift to Rail demonstrated several important outcomes, and among them, the outcomes of VP4 and VP5 of Into Smart 2 has been selected to be presented today due to their market uptake. Next slide, please. Okay. So the main achievement of VP4 and VP5 was the deployment of non-intrusive monitoring solution in Metro Milan Line 5, exploiting so the existing systems to be used as data sources, so without installing too much devices along the line to monitor both wayside and onboard assets, such as, for example, track circuit, to identify anomalies of track circuits, in particular to identify false occupancy events and try to prevent them, and to identify anomalies and degradation of the wheels of the trains. Also, ATS data has been collected to identify the most frequent alarms of all the signaling assets. And the main achievement was also the development of a decision support system to optimize maintenance scheduling based on asset status, and the development of an HMI to provide, to show the results and to provide users the results on an HMI. The partners involved in this project was Hitachi Rail STS as the VP leader, ATM, the infrastructure manager, Semosa for the data analytics, and Fraunhofer for the decision support system. Next slide. Into Smart 2 was done in the context of Shift to Rail, and it covers a free technology demonstrator. So starting from the TD37 for the data collection through heterogeneous monitoring system, passing through TD36 for the definition of big data architecture and the development of data analytics algorithms, to the TD38 for the decision support system, the intervention planning, life cycle cost analysis, and so on. Next slide. One of the objectives of Into Smart 2 was the definition of a common IMS architecture through the refinement of the architecture already identified in the previous project Into Smart. The aim was to provide a unique environment in which every use case could interface through an open standard interfaces. So from this common IMS architecture to the VP5 architecture. Next slide. The VP5 architecture follows the guideline of the common one, with the integration layer that serves all the blocks and functionalities of the architecture, the data connectors that collects the data from various data sources, the data hub to store the data, stream processor and analytics engine for the data analytics and processing, and the HMI to provide a dashboard in a unique HMI of every asset monitoring system installed. So using this architecture, two meaningful scenarios have been developed. So in the next slide, we will see the track circuit monitoring system. Okay. So in this case, existing signaling systems has been exploited to collect operational and diagnostic data of the track circuits, and algorithms, machine learning algorithms was developed for anomaly detection on the track circuits parameters. Furthermore, decision support methodologies has been developed to optimize maintenance scheduling based on asset status. And every result is shown in an HMI. Next slide. So going more in detail, every track circuit board was physically connected to a IMS server for data collection purpose. This data was correlated also to other data sources, such as the ATS logs, the maintenance data, and so on. And machine learning algorithms was applied to detect anomalies on the track circuits. And the results was displayed in an HMI through an alarm banner, and a link was provided in the HMI to focus on the anomaly highlighted. Next slide. One of the open call that supported this work is Daydreams, that developed prescriptive algorithms to provide suggestions on the activities to be done to solve predicted failures. So the outcome of Daydreams was a tool that was able to support the operators, improving the scheduling of maintenance processes. Next slide. Another meaningful use case is the wheel monitoring system. So several sensors has been installed under the rail and to collect the vibration data at each passage of the trains. This data has been, machine learning algorithms has been applied to this data to identify degradation of the wheels, and decision support system functionalities has been applied to the results of the analytics to shift from preventive and corrective maintenance to predictive maintenance. Next slide. So in accordance with the infrastructure manager, a new scheduling of maintenance activities has been provided based on asset criticality, asset status, and asset position. And the algorithms automatically generates new optimized scheduling based on the parameters that the user can customize directly in the interface. The comparison of the new plan with the fixed preventive one show the results that it was possible to provide 40% of corrective activities performed in advance respect of the preventive maintenance plan. Next slide. Okay, so the exploitation of the results of Into Smart 2, Hitachi and the infrastructure manager ATM are currently in the process of extending the services provided during the project and to introduce new functionalities to the platform. So the goal is to continue with the current solution in line 5, also adding new assets to be monitored, and then to add other section of the metropolitan area, other monitoring system to other section of the metropolitan area. Next slide. Of course, Hitachi will also exploit the know-how acquired during Into Smart 2, bringing the knowledge into new European project. In fact, Hitachi is involved in YAN4Rail, specifically in VP3 and VP4. And the goal is to develop an intelligent asset management system for the management of railway signaling assets in order to optimize the scheduling of train traffic in an Italian line. And that's it. Thank you very much.
Thank you very much, Giulia. And with this, we finished almost on time. And well, thanks a lot for this, but especially thanks for all the work that you have been doing, because these showed really that our program is not just there spending public money for at the end not achieving results. And instead, you are achieving good results, and those results needs to be shared. So with what we heard from the first presentation this morning, where Deutsche Bahn is already planning to use those energy saving on the connected driving system, any other operator can benefit from those results. So obviously we accompany the risk in Europe's rate. So we co-finance the risk on those that want to test before the others this innovation. But then all other actors in the rail system can really benefit of those results, because we are creating this successful innovation that is entering to the market. What is also important is that in doing so, in you having the possibility to know about those results and having access to this innovation, hopefully we are creating also a common level of innovation across Europe. Obviously, we're all starting on different situations around Europe, but as much as close we can, as much as we can get in a similar situation from an innovation perspective, the easier will be also to bring all together into the next step. And the next step is what we will be listening now. So the next step is the research and innovation that we're doing in Europe's rail. And in Europe's rail, we're dealing with flagship projects and largely focused on the greening and the digitalization, which are our main themes about how we can really bring the next step of the innovation in the rail system. So without further ado, I give the floor to our senior program manager, Lea Papies, that will present us the flagship area 1 and 2.
Hello, good morning. Hopefully you can hear me. For people in the room, I am sitting 5 meters away from you, but I think from a sound perspective for the people connected online, it's better if I connect here. Good morning, everyone. I'm here and I will start with the presentation of our first year achievement for the flagship projects, and I'll start flagship area 1 and 2, and I will also address the transversal activities, the TT. So if you go to the next slide, please. And the next one. Thank you. I'll start with flagship project number 1, Motional. So Motional is the project that is implementing in the first phase, flagship area number 1 on mobility management and multimodal environment and digital enablers. What it means is with FA1, we aim at developing a brand new or the future European traffic management layer. And that includes, obviously, train planning, operations, automations, ticketing, network management, and control. So the entire, let's say, life cycle from a traffic management perspective. The target is to reach, at the end of EURail, the delivery of a dynamic network and traffic management system able to operate at European level. And to achieve this, there are a number of technical enablers that are currently under development in order to reach this final solution. Obviously, in terms of benefits, we aim at improving overall operations, especially improving and increasing cross-border rail traffic. We aim at improving service offers for the final customers, so all of us here using on a daily basis railway, and we aim at improving operations and the capacity overall usage on the network. So Motional includes 4 big focus areas. So first one is on capacity management, the second one on traffic management, and the third one on integration of railway services with other transport modes. If you were connected for the first part of this General Assembly, you might have heard the colleagues from CESAR 3JU connected. We have a call ongoing, and when we talk about integration with other services and other transport modes, it is one big example of synergies with air transport sector. The fourth subgroup is focused on digital enablers, and this is the famous TT. So it's not solely linked to FA1, the traffic management part, but it is aiming at providing digital solutions for all of the flagship projects and to a certain extent also the system pillar. And I will come back onto that in a few minutes. Next slide, please. I will obviously not enter into the details of this view, but I think it's quite good to see and understand a bit what are the big phases of activities and developments inside flagship project number 1. I can say without fear that the same principle apply for FP2, and the same principles might also apply to the other flagship project, in the sense that the first year, this year, 2023, was hugely focused on the development of requirements and the development of specifications. We are reaching the end of this stage. Quite a lot of deliverables are coming to the JU now for review, and this will allow, starting from 2024 and moving forward, the development of prototypes and, of course, the first phase of big demonstrators that we are expecting at the end of this phase. So this is also mostly to show the approach that flagship project number 1 is taking that is also applicable for others. Next slide. Entering quickly into the main deliveries or the main results that have been achieved by the 4 subgroup of FP1. Capacity management, big focus obviously on specification. I will not come back onto that. We are getting delivery of those main deliverables, and this will be keeping us busy in the next few weeks in order to make sure that flagship project is getting feedback from us as soon as possible, and also feedback from other flagship projects, because you might, and we will come back to that with the other two senior program managers later on. There are synergies across FPs, and we want to make sure that requirements from another flagship projects are duly taken into account by, in this case, Motional when it comes to traffic management and the different use cases that are to be developed. As the collaboration with RNE, RailNet Europe, also addressed yesterday, has been established, and we hope that we'll be able to work jointly towards the same goal in the next couple of years. And so far, everything is on track in order to achieve this. We will also come back onto the maturity checkpoint later on, but in capacity management subgroup, we've had maturity checkpoint ongoing or already done in order to review those first set of specifications of requirements, and as well the collaboration with other FPs. It's been quite a big activity at the program level since September. Of course, the maturity checkpoints will be used also to assess maturity of the development later on, but they were quite useful now in order to secure that we were on the right track at program level. Subgroup number 2, traffic management, exactly the same principle. Specification deliverables are under finalization, so we'll be able to release them in a few weeks. Interactions with other FPs and SP and RNE are also ongoing. Those both subgroups are obviously hugely linked, as they are the core of the overall traffic management system. Next slide, please. So this is a first view of a system approach from Motional. It is not a final view, it is not a perfect view, but this is a start in order to show what we aim at doing. It might look complex like this. Some arrows might be missing. This is really a first release. I promised to FP1 Motional leadership to say this disclaimer, but I think it's quite interesting to start to have this view to start from and understand sorry, how we want to link different TMS from different countries for cross-border operations, how the core of a TMS from a capacity management to the daily operation and handling disruptions, handling maintenance is linked to other subsystems, whether it's the infrastructure, whether it's the train control part, or yard management, mobility management, and so on. So this is the first view. This picture will evolve in the next few months and the next few years, but very sorry for this. But this at least we have this first approach and system approach at Motional level. Next slide, please. Thank you. Subgroup number 3. The integration of railway services with other transport modes. I've mentioned it in the introduction. Here we're looking into seeing what results, for instance, from Shift-Rail IP4 could be reused, and also the integration with the different other transport modes. I've mentioned air traffic management, but it's also relevant for the automotive sector, road sector. Specification phase is under finalization, and development will start in 2024. Last but not least, digital enablers. I've mentioned it. It's the TT. If you look back at the MAWP, it's not part of FA1. It's the transversal technical digital enablers. And but still, in terms of implementation, it is included in FP1 Motional. Here, there is a lot of activities that have been happening this year. From starting with the federated data space, a brand new topic in the rail sector. And here we've had quite a lot of achievement in the past few weeks. Some of you might have been invited for town hall meetings that will take place later this week. We are starting to disseminate to the other FPs, to the SP, and overall to the community what is happening in the creation of the federated data space for securely and efficiently creating overall ecosystem for sharing data from maintenance, for instance, at the level of the rail sector. So more information on this will come in the next few months, but quite glad about the achievements that we have achieved so far. Digital engineering tooling, we are planning a procurement next year, but things are also moving in order to provide input to the different FPs, and is the same for the conceptual data model. A lot of work has been done in Shift2Rail, will continue in Europe's rail, but we expect to be able to provide support to the other flagship projects in the next few weeks and few months. Thank you very much. I think this is it for Motional.
Thank you. Thank you very much, Leah. Also here, if there are any questions, please write them in the chat and Leah will reply. Will you continue to flagship project 2, right? Flagship project 2?
I am. I'm just taking a bit of sip of water in order to not choke on myself and be able to continue. If you go to the next slide, please. Flagship number 2, R2Dato. Next slide, please. So here we are in the realm of traffic control. With the final main objective to further improve railway operations by bringing digitalization to all automatic train control aspects. So we're talking here about ATO GOA 3.4. It's a good continuation from the presentation from Benoît Bienfait earlier. We're talking about enhancements on train positioning, moving block, onboard communication, and everything. In terms of focus areas, we are on 6 main clusters, 5 dedicated to digital, to technical developments, and the 6th one focused on the demonstration. If you go to the next slide, it will be even easier to understand and to visualize. This is the project where I've just mentioned the automation processes cluster, the optimized headway with the moving block and train positioning, among other digital technical enablers, enabling digital technologies with the 3rd cluster where we have connectivity, the modular onboard platform, digital register, We have as 4th cluster the fast and effective deployment with the DevOps, new modeling techniques, all the deployment and migration aspects, and the testing and validation and certification enablers. Obviously, the idea is to ensure that we not only develop new technological enablers, but that we can also easily, further down the line, make sure that they can reach the market. The 5th one is focused on new and innovative operational solution. Here we have the self-driving wagon, quite interesting for our colleagues in FP5. We have virtual coupling, obviously continuation from Shift2Rail, and the autonomous route setting. Like I've mentioned, demonstrators are gathered in a cluster, and we'll have demonstrators focusing on different key use cases and key market segments, from freight to regional and to high speed. Next slide. What results have we achieved in this first year? Same principle as FP1, a big focus this year on making sure we get the requirements right and working on delivering the first set of specifications. And I can say that for cluster 1, everything is on track so far. Benoît Bienfait has mentioned it in his presentation. The idea is that EU Rail is taking over the final set of specifications developed in Shift2Rail on GOA 3.4 and further improve them, adding use cases, adding different type of enablers. And one of the big achievements this year is to agree on this, what is being called baseline 0 for EU Rail, and a proper reuse of the results that we have achieved in Shift2Rail. This is one big achievement. The second big achievement is that the requirements have been developed and the specifications as well. and there is an ongoing maturity checkpoint. So all the FPs have been quite busy in the past few weeks reviewing what R2Dato has delivering in order to make sure, like I've mentioned, that all the requirements from different FPs have been taken into account. So this is ongoing. Results will be available in the coming 2 weeks, but for the moment, everything is on track. Cluster number 2, optimize headway. Here, same principle, specifications are coming on the table. No big delays to be reported, whether it's for moving block, for the train positioning. Specifications are coming in. For train positioning, I'd like to flag that in addition to the work that was initially foreseen in R2Dato, this year we also developed what we can call a sub-project together with the system pillar, with the European Railway Agency, with the European Union Space Agency, EUSPA, and the European Space Agency, ESA, in order to develop this dedicated rail signal or augmentation that we can use in the demonstrators that are foreseen in R2Dato at the end of phase 1. So this work is ongoing and is partly also integrated in R2Dato, and it's quite a nice and big achievement this year as well to make sure that we get the rail requirements properly channeled to the space agencies. Next slide. Cluster number 3, enabling digital technologies. Same principle, use cases and requirements have been developed for onboard communication. We are getting intermediate deliverables for the modular platform. So first approach is coming into fruition. And we will be, as I've mentioned, busy reviewing all those big initial technical deliverables in the next few weeks at the JU. But as I've mentioned, there's no big delay to be reported. So far, we are on track in order to get into the development, and the future testing in phase 1. Cluster 4, fast and effective deployment. Business case, first outline has been delivered. And on the DevOps and architecting for evolution side, same thing, first set of specification is going to be delivered. So we will see in which direction we are on this cluster. Next slide. Cluster number 5, innovative operational solution. So here we are getting a first initial results for the use cases for the self-driving freight wagon. So the work is ongoing. Obviously, we are talking about, like the name of the cluster, more innovative solutions. So we are slightly less advanced in terms of specifications, but the work is ongoing, and so far everything is okay. Cluster 6, demonstrator. It's not because we're demonstrating in not tomorrow that the work cannot start, and preparation are on the way. Whether we're talking about the ATO, whether we're talking about moving block and all the different technical enablers that need to be tested and integrated in bigger demonstrators. So this work is ongoing, and a few issues are happening, but nothing to be concerned of for the moment. But we still have time in order to make sure that those big demonstrations that we were expecting at the end of phase 1 are happening. And this is my last slide, and I thank you for your attention, and I hope that I've presented a good outlook of what FP1 and FP2 are doing. Thank you very much.
Thank you very much, Leah. So these 2 flagship projects, as you have seen from the explanation of Leah, are really key because they touch the core of the system in terms of controls of the safe movement of the train. If you're looking into flagship project 2 and new technologies to make it better, but also if you look at flagship project 1 on how the entire fleet can be managed in a better way, and especially how we can ensure coordination across countries in an optimized manner. It's clearly not an easy exercise. It's an exercise that it must include all the stakeholders, a lot of stakeholders, and it's also something that is challenging because of the size of the complexity of the matter, because we're looking at European Union level with plenty implementation that already exists at the local level. So we will see also later on how the system pillar can help us to standardize and regulate all those activities. But before that, we are going to have a look to the flagship area 3, 4, and exploratory research. Why exploratory research is added there? Simply because our senior program manager, Sébastien Denis, that will do the presentation, is in charge of this portfolio. So, Sébastien, the floor is yours.
Many thanks, Giorgio, for the introduction, and good morning, everyone. So I will indeed present today the first results of the flagship area 3 and 4, a bit with the same logic than Leah. This is the first year of the project, so I do not have so much tangible result to present, but it doesn't have prevented the project to perform a lot of preliminary activities in order to have and pave the way of the future results of the project. So next slide, please. So the flagship project number 3, IAM4Rail, so the holistic and integrated asset management for Europe's rail system. So in a nutshell, the project has for objective to deliver solutions to minimize the asset lifecycle cost, so mostly maintenance, but not only, and also to extend the service life of the system while improving the reliability, the availability, the maintainability, the safety, and the capacity of the railroad system. So the targeted solutions are a different application of intelligent asset management system, addressing both rolling stock and infrastructure assets, and also technologies for the automation and robots for maintenance, execution, and construction. Okay. So the project is based on various independent use cases, about 50 plus, but that we can cluster somehow in 5 areas. So the first one is all the use cases, that typically 2 use cases that have developing solution for wayside monitoring, but with a direct link with the TMS. The second cluster is for all the use cases associated to rolling stock asset management, such as a traction unit or wheel set. Then the third one on the infrastructure asset management. So here as well, covering a various aspects of the infrastructure network. Then the fourth one on the railway digital twin. So here the consortium has clustered all the use cases based on full digital twin and BIM methodology. So with the idea to have a joint methodology across use cases. And finally, in the cluster number 5, all the remaining use cases for component developments, but also maintenance execution use cases with wearables or also robotics application. So next slide, please. So here I will not come into the details of this graph, but just to present a bit the holistic approach that the consortium has chosen in order to develop all these use cases. So they are developing a concept for all the YAMS application. So the idea for all the use cases remain basically the same. So there is first of all the collection of the data. So either data that are generated by the project with wayside data or onboard data, but also data sources that are exploited and coming outside the project, such as weather forecast. And all this data are collected and aggregated into a data communication layer where they are processed in order to provide, I would say, useful information for the end user. So when you talk about end user, it could be final customer, could be entity in charge of the maintenance. And in this, I would say, final user interfaces, the project is developing support for the decision making, friendly HMI interfaces, and etc. And this is where I would say the project is tailoring and customizing the work in order to fit for the customer needs. Okay. Next slide. Okay, so coming into the detail of the results per cluster. So in the first cluster, we can report that there have been a general architecture that have been already designed and shared, because there are two use cases, as I mentioned, for this cluster. So it was important to have consistency, especially in the architecture and the interface with the TMS. So it has been produced. And there is also the physical activities or installation that are ongoing with the start of the collection of data. So for the moment, with a limited set of devices and systems, but it will populate the historical data source that will be later used by the project for the application. For the second cluster on the rolling stock asset management, so here the definition of the use cases, and the associated KPI have been done. So it could sound like a minor achievement, but when we talk about the definition of use case, we don't simply talk about a small paragraph. There is behind that also a preliminary architecture that have been developed, also the data sources where the data will be collected have been identified, etc. And there is also a detailed demonstrated activities that are on progress. Okay, so this is true for basically all the use cases. When I talk about use cases, I'm not talking about a small definition, but really a first concept of the activity. Then on the next slide. For the cluster on the asset management, so beyond the definition of the use cases for all the activities foreseen for the infrastructure asset management, there have been a first version of the demonstrator vision and architecture global for the railway checkpoint. So it's something that have been already reviewed by the system pillar and the colleagues from the flagship project 5. And based on this first, I would say, interaction with the stakeholders, there have been an agreement to install a cross-functional team under the leadership of the system pillar to emphasize and ensure a proper collaboration and consistency with the development done in FP5. So it's one example of the and one good example, I would say, of action that have been taken to reinforce the collaboration and the synergies between FPs. On the top of that, there have been, I would say, reshaping of the activities regarding this connection-based maintenance algorithm. And finally, for most of the use case, the definition of the location for the test and the preliminary, I would say, system to be monitored has been already defined. On the cluster 4 for the railway digital, still the previous slide. On the cluster 4 for the railway digital twins. So here, there's also a good progress to be reported with some definition of the beam station to be tested and done. But I guess next year there will be much more progress to be and tangible results to be reported. And then the next slide and the last slide for FP3 on the environment, user, and worker-friendly railway assets. So here there is a joint effort to have a common robotics platform developed within this project, and one of the most tangible results that I can report is this selection of the middleware that will be implemented for all this robotics platform. There have been also some preliminary but very, I would say, interesting demonstration done for some of the use cases. So one regarding the placement of balises on tracks for a signaling system. And additionally to that, there have been also work on the specification and requirement for the future results on wearables and also augmented virtual environment and robotics activities. So in a nutshell, this is what we've been done for FP3, and I will go directly to the next project, FP4. Yeah, it was just to mention there is no major concept for next year activities. So for FP4, we can go to the next slide here. So FP4, so Rail for Earth, sustainable and green rail system that have the main objective to deliver solutions to minimize the overall energy consumption and the environmental impact of the railway system. So addressing both rolling stock, mainly the most part of the subsystem that have been addressed into the project, but also infrastructure and stations use cases. Okay, and in the addition of this objective, there is the I would say goal to have an healthier and also more attractive and resilient against the climate change added value from the project output. Okay, so here as well, the consortium has decided to cluster the activities more per subsystem. So the first subsystem will deal with the alternative energy solution for rolling stock. So basically all the BEMAU development as well as the hydrogen solution for onboard unit. The second one is all the use cases for the energy in rail infrastructure and station. The third topic is more transversal, is for the sustainability and resilience of the rail system, tackling diverse topics such as noise and vibration, circular economy, adaptation to climate change. And so this is somehow transversal to all the other sub-projects. Then the electromechanical components and subsystem for the rolling stock are somehow tackling solution to get rid of any pneumatic devices, and so giving a solution to have much lighter and much easy to maintain solution for rolling stock and especially passenger trains. Cluster 5 for healthier and safe rail system, so addressing a HVAC solution, and the train's attractiveness, so the follow-up of the shift rail activities on the interiors with a similar approach, but with a wider scope. So if you go to the next slide. Next slide. So here I don't go into the details. It was just to highlight the dependencies and the synergies between the different clusters. So with the cluster 3 on the top, as I said, that is transversal to the two main areas, the rolling stock and the infrastructure and station development. So we can go directly to the next slide. So here some of the few results, and my intention, especially regarding time, will not be to go point by point, but really to say that as first results and maybe the most important result, the initial intention from the project to have BMU for passenger train with an autonomy of 200 kilometers are, for the moment, and thanks to the pre-studies, feasible. So that's a really positive, I would say, outcome of the project. And it gives them a lot of confidence that the project will, I would say, deliver at the end of 2015 their intended demonstrators. And then for the infrastructure and station platform, you will see here many activities and but still preliminary activities done regarding H2 development and also smart grids development as well. Next slide. So here for the sustainability and resilience of the rail system, maybe one point I would like to highlight among all these bullets, this is the work, innovative work that is being done by the project regarding the adaptation to climate change. So there have been an extensive bibliography exercise done with more than 220 documents reviewed. It's something that is a bit new for the sector, and so I would say that Rail for Us is a bit precursor in this work that is extremely important for the railway sector, and so we are all aiming to have really good results and significant results from these 4 years of activities from the project. Regarding the electromechanical components, here I will just say that the activities and the preliminary activities are developing as per the plans, so I will not go into the details of what you can see on the screen. Next slide, please. So for the two last sub-project here, no details neither on the top of one that's been displayed here on the screen. Just maybe to highlight that among the preliminary activities for the ventilation, just to say that it's covering two aspects. So not only the rolling stock, the interior rolling stock use case, but also all the air quality for the covered platform and tunnels. So just to mention this from this last slide. Okay, so if we move to the next slide, I just wanted to highlight that the project is indeed in the good track, so no major concern for the next year. Just maybe one specific point of attention for one of the use case on the electromechanical brake demo, but green light, if I may use a traffic code. Exploratory research, very quickly from my side, especially as Giorgio yesterday, I've been presenting the objective of this sixth first exploratory research that we launched last year. As you can see, this project has been launched only during summertime, so it's a bit preliminary to report results for them. So I will not give, I would say, any details on that, but I will be pleased in a year time for the next event to really give you the first results of these promising projects. And so the second area of the exploratory research that we performed this year, this is displayed in the next slide. This is all the work that we have been preparing in order to have the second launch for the second exploratory research call launch into 2023 with six independent exploratory research call. It has been an intense exercise because the sector has fed us with a lot of very good ideas, so more than 80 plus ideas, and in order to populate the I would say exploratory research content. And here, following diverse consultation, analysis, etc., this is the top 6 really of what we are aiming to have populating the 220 for the next years of exploratory research activities. That's it from my side. Thanks everyone for your attention.
Thank you very much, Sébastien, sorry. And what we have seen indeed are, let's say, more results that, or actually activities that we are conducting using digitalization, especially for infrastructure, but also some hardware development in flagship area 4. And for this exploratory research, I see that is missing a P. We will add it. For this exploratory research, I think the message that this graph would like to pass is that we cannot predetermine upfront, like instead we are having with the flagship area, which kind of activities we want to do. It's by the name is exploratory research. So every year or every time we launch a new call, we needed to have a bottom-up input coming from the sector, and this is the reason why we're consulting with IRAC. We are taking any input that the running project are providing to us, the member are providing to us, so don't hesitate to bring up this input, and obviously there will be a selection, but it's not an exclusion in the sense that all those ideas for the moment are staying in our drawer, but we can obviously put them out as much as needed. The selection is also made based on the budget availability. Obviously, also there, the more budget Eurotrade will have, the more ideas and the more research activities we can launch. But also, I think a collective work that we can do if you are successful with your research results activity, we can also aim of asking also more support from the youth. We go to the next part. The last presenter for this session will be our senior program manager, Javier, which will present the flagship area in his portfolio, which are 5, 6, and 7. Javier, you have a challenging time frame to do all this presentation. Go ahead.
Thank you very much, Giorgio, for the introduction. I have 15 minutes, right? So I will try to stick to the to the time. As Giorgio mentioned, I will be presenting for you today in this time the main outcomes and results from the flagship projects 5 and 6, and then introduce also the activities on flagship area 7. If we go to the next one, you can see in the slide a bit the summary of the scope of activities of transforming Europe's rail freight project, the FP5 transformer, with the main figures of the total project cost and the main activities in which the project is basing its activities. You can see here in the center that the digital automatic coupler is the central enabler of the project. You were also informed and addressed yesterday about the challenges the sector is facing to make this a reality, and then from the research and innovation side or point of view, we are trying and we are pushing for these activities and for these solutions to be a reality. You will see a bit later on a bit more on the details on the activities, but here just for you to see and for your information the number of partners that are involved in the activities and how we are aiming to demonstrate this technology up to a technological readiness level of 8. Of course, the project is all these activities are contributing to the package of policy initiatives of the European Green Deal. So in order to set the European Union on the path of a green transition and of course contribute to this climate neutrality and do well on those aspects. If we go to the next one, you can see the objectives of the project in the next one. Yep, here the previous one, sorry. Too fast. The objectives of the projects are, of course, to reach this European harmonized and scalable DAC solution that will, of course, support the digital yard automation and manage these activities in this operational aspects, of course, through enabling these digital operational procedures with also the activities that are touched upon the different work packages that I will present later. These activities will, of course, have an impact on minimizing the physical works that at the moment is done in operations. Well, this manual coupler is still in place, and of course aims to automate and digitalize these operational processes. To provide, of course, this flexibility and reliability of the service by also providing and demonstrating within the activities of the project that these solutions are ready for a market uptake and for a implementation on the operations. If we go to the next one, you will also see that these objectives are linked to a more societal part of these activities dealing with the economic growth that this will provide to the industry and increasing the productivity, the efficiency, and of course to secure that this economic growth is supporting the European competitiveness of the industry. This will also have an affection on the demographic, on the activities that are at the moment carried out in these operations for freight. So it will be or it will optimize the way the resources are allocated for the transformation and in order to optimize these operational activities. Of course, we are touching, and as it was also presented to you yesterday within the EDDP, some aspects related to the financial and political pressure that is included on this operational and these activities which have a huge impact for the sector. And as I was mentioning before, these activities, of course, are contributing to the achievement of reduction in the footprint we have while operating freight. If we go to the next slide, you will see that the project is organized, so has two main areas in which they are centered. Well, the first one is, of course, the full digital rail digital freight operations, FDFTO, in which by supporting and developing this digital automatic coupler in the different types you can see here, of course, ensuring that the energy and the communications will be provided and the train functions that have been agreed will be part of this implementation will, of course, improve these automated operations in the yards and operation activities as a whole. The cluster one that is developing or is trying to harmonize this technical solution on the DAC is, of course, enabling this second area, that is the seamless rail freight, in which the project is, of course, integrating all modes of transports in order to have a seamless planning and dispatching of trains when it's time to put them on the tracks. In the next slide, you will also have, well, it's for you to have an overview on how many entities are involved in these activities, different member states, different operators, infrastructure managers, industry members, research and innovation centers. So it's not just an initiative which is focusing on the implementation of better operations in the future, but also putting on those solutions all the research and innovation capabilities that the JU is able to put together. In the next one, you will see also that the approach of the project is, as I was mentioning before, focused on these two main areas: the DAC specifications on the full digital freight train operations, so to ensure that these specifications are stable and are agreed throughout Europe, and of course the seamless activities that are linked to those operations or to those specific train functions that will be put in place. On the next slide, you will also see that the project is, of course, addressing all those activities and put them into demonstrations. You can see here the planning on how the demonstrations of these trains is going to be done during the lifespan of the project, involving the different types of DAC, the different countries, and the different activities that will be, of course, be on board of those activities, with the yard demonstrations, with the railway checkpoints, with the multimodal and corridor cases being implemented in here. I will rephrase or will present later some of the challenges the project is facing that we can see in the next slide. As you can see here, we have during this first year, the project has already achieved quite major achievements in relation to DAC. So the mechanical part was already selected. Some major progress on the definition of the operational functions have been already broadly presented and is up to the final approval to be agreed and established. These target operational procedures have been, of course, widely discussed, as was also presented yesterday within the operators, industry, the EDDP. And this, of course, involves a lot of standardization activities that are somehow part of the challenges that the project is also facing, and how the interactions with the system pillar are ensured in order to be able to provide good and the good basis for the testing activities that the project is going to be performing. On the seamless part, also to mention that there have been already the reports and of course approved already in the maturity checkpoints that we are carrying out within the JU on the basic functional requirements defined, and of course also dealing with the activities or providing input to the activities of FP3, as Sebastian was mentioning before, on CMS. And also presenting here a bit for your information, the milestones that we are aiming to achieve in 2024 with the finalization of the first DAC specifications, the first FDFTO system architecture and the functional requirements, and of course, the decision on the e-coupler that should be soon be agreed, as well as the provision of the DAC5 ready. In the next slide, and just to present a bit of the activities the project is also doing in terms of disseminating the activities and promoting all the work that is done. You can see here some pictures of the opening of the train test lab, where there were also presentations, demonstrations being done, and of course introducing the activities of the FP5, as well as on the next one, next slide, some activities linked with the DAC4EU events that have been also that are also somehow linked with the activities of the project of FP5. With this, I'm finishing the presentation of FP5, and just to mention as a main risk or main issue that the project is now facing is an updated time plan of the project that will be committed or will be drafted within the next within the first quarter of the year, but is in order to align the demonstrations and the operational or the train functions linked to those demonstrations is a work ongoing. Yep. So quickly on flagship project SIS, that is delivering innovative rail services to revitalize capillary lines and regional rail services. A bit also for you on a summary slide, information of about the project and how the objectives in order to ensure this viability of regional rail by reducing the cost of ownership is ensured. The project is touching upon those challenges by touching on the specific bullet points you see here, lowering the CapEx system cost, lowering the OpEx, increasing the productivity in order to improve the customer satisfaction at the end. You can see in the next slide the detailed focus areas of the project. Here, the project is, of course, through the activities being done for the regional rail system solutions and defining the architecture, is going to optimize on innovation solutions to make the rail regional services more attractive and cost efficient for these services. The project is also touching upon these regional rail CCS and operations systems, of course, taking into account that the regional rail assets would have to be considered in a cost and efficient manner to sustain these operations and reducing these overhead costs. And then the project is also contributing to the activities on defining designs or conceptual designs for regional rail rolling stock. And of course, as mentioned before, in order to provide these optimized services for the customer, they are also including some activities on the way they will implement or accurate these options for the customers at the end, in order to make this transition from other transports, other modes of transport to rail in a smooth manner. In the next slide, you will see that the focus areas, well, these are the work packages in which the project is structured. And in the next, and also to highlight that overall the planning and the activities of the project are aligned and matching the grant agreement baseline. So no major concerns so far. As mentioned also before, the status of the project is in a good situation. And you can see in the next slide the different focus areas. In the next one again, the different focus areas and the main deliverables that the project has already been providing. In the next slide, you can see this you can see this, it wasn't here. You can see that the information that, well, the project has been already delivering on the different focus areas by defining, as also mentioned before, the operational and functional requirements, and of course, contributing to the different focus areas within the activities of the project. Major achievements in 2023. You have a few here. There was the first advisory board meeting back in March with a good participation of stakeholders, and special interest was put on the technical enablers and the demos of the project. There will be a follow-up meeting soon, and then you can see also that the project has been very active in communicating and disseminating the activities through different events worldwide, as you can see. In the next slide, you can see, well, that was the slide I was referring before in the different focus areas, how the project has been delivering basically on these operational and functional requirements, and of course the interactions on the from the different work packages to the work being done. Next, please. Yeah. Here, just to highlight the main issues that have been successfully mitigated, as we were mentioning, also presenting before. Within the JU, we are carrying out these maturity checkpoints in which this harmonization and alignments that will be presented again in detail after this presentation. We are touching upon those issues to solve these open topics that might be linked to these interactions between FPs, but no critical and blocking issues are identified at the current moment within the project activities. Yep. Next one, please. And here about something just to finish the last slide on FP6. The outlook of for 2024, the intention is, of course, to finalize and consolidate the requirements and the architecture within the activities of the work package 2. There will be final releases of technical deliverables in the work packages you can see also here, linked to this focus areas presented at the beginning. There will be the setup of the demonstrators concept for the project technical enablers in work packages 8 to 11. Also activities linked to the integrated demonstrators concepts in work package 7. Continue with the dissemination activities and of course ensuring the involvement of the advisory board members within the activities of the project. So that's the outlook and the intentions of the project for the next months. Next slide would be to briefly present on the activities of the flagship area 7. And as you can see in the next slide, the flagship area 7 is addressing not only the activities linked to the automated guided transport solutions, but also is trying to explore these emerging systems that could create opportunities for innovative solutions. At the moment, there were 2 projects that were subject for funding within the call within the second call that was launched in 2022. One being pods for rail, which is developing a concept for pods on railway to identify also relevant use cases and business scenarios, and then made for rail that started also in July, and is the main objective is to explore these non-traditional maglev data solutions to address the technical feasibility of those and effectiveness of these systems, considering also technical and economical performance. Within 2024, the EU Rail Undertaking is expecting to launch a topic dealing or touching upon the Hyperloop technology. And this will be also focused on defining the operational safety and reliability aspects, also assessed by economical viability of the solutions to be promoted. So this is in a nutshell the progress in 2023 for FA flagship area 7, and that's concluding my presentation today. Thanks. Any questions, please don't hesitate.
Thank you very much, Javier. So again, for the question, maybe it's better through the chat. We're a little bit delayed compared to our planning, but I think it was important that you could conclude it. We're also a little bit delayed for our coffee break. What I suggest is that we're having a coffee break in a shorter time. So maybe to have just a 5 minutes coffee break, and then we come back here at 11:25. 8 start, well, 11:25, maybe it will be 11:30. And just for everybody to know, for those of you who are in the room, at the end of this conference, we will do a nice picture. So don't immediately run out. So we will do it, but not now, later on. So we can use a 5 minutes coffee break. Thanks a lot. So for those of you online, we are restarting the meeting as well. We will restart now with a presentation on the achievements in 2023 of the system pillar. Maybe those of you who want a coffee, take it in the other machine. Now for this one is today.
Yeah.
Okay, very good. So I give directly the floor to our head of system pillar, Ian Collon, that will introduce this system pillar overview. Ian, the floor is yours.
Thanks very much. Good morning to everyone. Just to note, Stefan Schmidt is ill today, so he won't be presenting. So it'll be myself, Christoph, and Paolo. If we can go to the next slide, please. And again. So yeah, so the set of slides is essentially to give a broad overview of the context and rationale of the work within the system pillar, and then a view on the state of play, an example of one of the outputs, the trackside asset specifications, which was published in June, and a discussion on the standardization TSI input plan, which should be released in the coming weeks. So I will start briefly and then hand over. Just first of all, on the system pillar itself. So it was an innovation within E-Rail compared to Shift to Rail. It was part of the Single Basic Act. It is a specific stream of budget and governance, essentially to support the integration and coordination of the evolution of the system. So obviously the bulk of the money within Europe's rail, the bulk of the work goes on the research and innovation into specific improvements to the system. But one of the lessons learned from Shift to Rail was that there is significant value in there being a more coherent and comprehensive bridge between the world of research and innovation and the world of harmonization. So the system pillar aims to essentially bridge this gap and in the end make a more efficient process from the research and innovation work into the harmonization work, the development of specifications, the development of standards, which for European solutions is a necessary step into the implementation at European level. The other main purpose of the system pillar, and I should emphasize here, and if we can go to the next slide, whilst the scope of the system pillar is indeed for the whole railway system, I mean, the focus and the clear focus is on the control, command and signaling and linked activities. This is what is provided in the legal base, and it's essentially a question of resource availability. We cannot focus in very great detail on every single aspect of the rail system. So CCS is the area, and CCS linked activities is where there is focus. But also the aim then here in the CCS area, at least, is to provide an overall umbrella for many of the initiatives that have previously been carried out in individual places or in organizations. So, for example, on the CCS side, there were initiatives like Cora for the onboard CCS, like reference CCS architecture for the trackside CCS, like ULinks for elements of the interlocking specification, plus all of the work that was going on in Shift to Rail. And there was a request from the sector that there be essentially an umbrella to cover all of these activities, so that in particular from the supplier side, there was a coherent view on where the focus should be. So if we're looking at the evolution of the onboard ETCS unit, the modularization of that, to what extent should the work that's been done by a core be taken into account, or connector that's in Shift to Rail, or additional work that's happening, for example, on absolute safe train positioning? So the purpose here is to really provide a consolidation and point of focus for all of that work and all of that valuable work into one overall umbrella with a close coordination of the sector and suppliers. So this is the broad overall context. We aim to provide the bridge between the RNI and the harmonization world, and in the CCS area, we aim to provide an umbrella, a focus for all of the initiatives that are happening, so that there is one place to look and coordinate the activities which relate to the evolution of the CCS system in Europe. That's the broad context. I will now hand over to Paolo to give a bit more detail on the general goals and setup, and then to Christoph to talk about the work that has happened in this first year, and then I will take up at the end of the presentation. Thanks.
Thank you, Jan. Paolo Ciucci, I'm part of the core group. So as Jan already introduced, in the system pillar, the general goals are mainly to streamline the product specification, means eliminating the 40 variants national variants that we have in the sector. This should be is the key to simplify the specification and simplify the products that are now used in this market. Improve the reusability of this product, because with the simplification we can reuse with the same specification. We can use product across Europe, and then this will simplify also. It will mitigate the shortage of the resources that we have in the sector, means reusing the product with the same specification, with the same interfaces and the functionality. The goal is also to introduce the modularity in the system, where each product, each component of the system is we have defined the functionality and defined the interfaces, input output, in order to improve the interoperability, exchangeability of the product, and then with this will also increase the competition and boosting the development. Then the other aspect, the most other aspect is the automation, means focus on ATO up to grid automation 4. Traffic management, having more precise information, we can improve the functionality of the traffic management system, both to manage the cross-border traffic, but also to be more precise to improve the functionality, like a conflict resolution, conflict detection, and so on. And last but not least, the digital automatic coupling for the automation and have a system that is able to provide the right information to the CCS system regarding, for example, train length, train integrity, plus the automation of all the activities that we have in the yard for composing the train. You can go to the next slide, Jan. So in this picture, in this slide, you can see our working method. On the left side, you can see the 4 steps, the most important steps that we are following. Means, first of all, harmonization of the operational rules. This is the key to have what we say the standardization and simplification of all the products used in the CCS system. Create a consistent target architecture, so an architecture that can be evolvable with the modularization and save the investment on what has been already equipped and used in the system. Support the migration. This is one important aspect in our work in defining the architecture, because the important part is give the possibility to each infrastructure manager to decide which is their position, because each one starts from different position, different situation in their nation, and then give them the possibility to decide where jump in this path toward the standardization, the harmonization of the system. This is it's important to have a strong cooperation with the infrastructure manager to understand really which are the needs, and for us to design an architecture that is flexible enough to allow this stepwise approach. Then define a proper granularity of the system. When we say modularization, we need to think about modules that will be part of the system with the right level of organization that will be agreed in the sector. And this means that in this architecture, each box, each component of the system is a black box where the interfaces are well standardized, well defined, and also the functionality provided. But inside the box, this is up to the suppliers to identify exactly which technology they want to use it to deliver the functions that are requested. On the right side, you can see how we are approaching the total system, and we layered the total system in 4 or 5 layers, where you see on the top the railway system that is a part of the other transport system. You can see bordered in red, the railway system integrated in the network of other transport system, buses, rail lines, and so on. Then the other layer that is the more focus of the system pillar. You can see in the middle the TMS and CCS that is the focus. And then the relationship with the other system part of the railway system means power stations and all the other systems, that the diagnostic and so on, that are part of the railway system. So the focus is really on CCS and TMS, but also the interaction of the CCS TMS with the other systems that are part of the railway system. And then going down in the layers, you can see one of the boxes, for example, in this case, the TMS box is exploded, the CCS box. You can see it's exploded in many other boxes, and so on. So we are going down, and our organization reflects this kind of approach. And for each box, we have a dedicated team that is focused on specification of that box, take into account the interaction with the other boxes that is upper level. So in the end, we identified the 4 layers, and in some cases we will have also the level 5 layer, means inside the box. In some cases, for migration purpose, could be needed to investigate a bit more inside to understand if this is need to be specified or can be left leave it in as a black box. Next, Jan. About our organization. So the system pillar is organized as a core group on the top, where we have all the representatives of the sector. And then we identify the 4 tasks. The task one, so each task, of course, the leadership of each task is still one representative from railways and one from supplier. Then we have task 1 that is dealing with the high-level architecture, so the first layer that you have seen in the previous picture. And then task 2, that is the focus on control and command and signaling. Task 3, traffic management system. And task 4, it's the digital automatic coupling. The biggest task is the task 2, where we have the most of the resources. But this task and the people inside this task are organized as a domain, have the role to define the specification and also to interact with the innovation pillars to harmonize the specification and cooperate in the definition of the system and the specification. One of the most important activities of the system pillar, means all the people that are involved in this organization, is to harmonize all the results that is important, that we already had, and as Jan said before, all the previous experience of core RCA, shift to radio, links, and so on are reused, and we do not start from scratch to define the new system, but reusing as much as possible and harmonizing the result of this project in order to have a specification that is coherent with the architecture that we want to deliver. I think this was the last slide, Jan, and I don't know if there are questions, otherwise I'll give the floor to you.
Yeah, okay, then thank you very much, Paolo. I take over. Well, welcome also from my side. Maybe directly next slide, please. I would like to start here a little bit with an overview of the architecture we are seeing here. And most importantly, what you could see here, it's overall, it's the harmonized operational process, because what already had been said, we would like to deliver a harmonized architecture, and this can only be fulfilled if we also have the harmonized operational concept. Here you see all the, let's say, main building blocks and the areas of activities. I don't want to read them all, but mostly important to mention that the final deliverables we will then create out of the work of our system pillar are mainly then the interfaces. And therefore, beside the blocks itself, we're also highlighting a little bit here on the different interfaces. We're focusing our work on in the system pillar to derive out of the work the standardizations for these various interfaces to make sure that the systems are working together and that we finally have a modularized system with, let's say, the right level of granularity, that we find the way between modularity and also then effectiveness of the development. So maybe we go directly to the next slide. Here a little bit what was the year 1 content, and you see here we have sorted this according to the tasks, starting with the railway system task 1. First year focused very much on the let's say current system as its architecture, but also then delivering a report on the energy savings in rail with a lot of ideas and initiatives what can be done there. But also we delivered from the overall activities the SEM, the engineering management plan, work on common business objectives and the overall guidelines for our work in the system pillar. In task 3, TMS and CMS, we are worked mainly on the traffic management concept and on the functional allocation between the CCS and the TMS. Here, already mentioned before, DAC, FD, FDO, we have heard what will be done in the flagship project. And here we're complementing this with the, let's say, with the interface between CCS and DAC, a very important topic because it's a vital interface and it's a new one. The wayside architecture, what's at the moment called central instance, and then mostly also importantly, the alignment with the FP5 project, what we deliver out of the system pillar. As already said, CCS is our focus topic here. And we started already with the harmonization concept for 12 of the 31 areas of operational processes. We started also the architecture, also especially on the wayside, but also on the vehicle system. We delivered the first standard also for the interface for the object controller. You will hear more about it in a second. Then moving block and ATO are two important topics where we also started to have the first design principles. Next one, the harmonized APIs for decoupling hardware and software, also for safety systems. Very important topic. We work intensively also on security, that security will be part of the design of the system pillar. And last but not least, we had also been involved in the interface to FRMCS to align also with the content of the version specification version 2 and 3. Maybe we go directly to the next one. And here we will highlight a little bit on the challenges, because what we would like to do is we're changing a little bit the practices, how we collaborate in the sector. Already said, we have a coordinated program for architectural planning, and we would like to really go for more a harmonized and well-organized activity. We have now working 250 experts working together to speed up the harmonization, but also it means 250 people means also, let's say, bringing all up to speed. It's a collaboration between railways and suppliers on a daily basis, and this is maybe one of the important success factors, that we continue to have all aspects of harmonization and of this standardized architecture together right from the beginning. You could see also here we're talking about the system of systems approach. That means the complexity is relatively high. So it's important that we have this in mind, and we also have, let's say, a structured way of working. And then you have seen this also from Paulo's presentation, that we really, let's say, work here in a coordinated way and help also with the help of tools. Maybe directly next one. Here a little bit what has been achieved. So governance is in place with the core group, with the tasks and domains, the main leads, also with the steering group. Then we, as already said, we have a standardized system of system approach and the engineering process behind called SEMP. We also have revised the first version and accepted this in the steering group. We have a tool chain in the background, what helps us to coordinate the work with all the large amount of people, with Polarion as the ALM tool, application lifecycle management, and then the Capella tool for the model-based system engineering. One of our main activities also going forward in the next month is the STIP, the Standardization and TSI Input Plan. You will hear also more about it in the next minutes. We have, and this is also mostly important, established a process for the interaction between system pillar and innovation pillar. We are contributing here to the maturity checkpoints. We have alignments with Flagship Project 5, but also intensively with Flagship Project 1 and 2. Because this is really crucial that the results of the system pillar and the innovation pillar are aligned as much as possible. We have set up a new project or new subject, the Harmonized European Railway Diagnostic investigation. And then last but not least, request for service is now signed also for the second year, so that we can continue to work what we have started also in the next year. That's all from my side, and then I would like to hand back to Ian.
Thanks, Christoph. Thanks, Paolo. So I'll now give a brief example of one of the outputs from this year. So if we go to the next slide. So we published on the 30th of June. Also, at the same time, this was published on the EU-Links website. The release of the trackside asset specifications, essentially the baseline for release 2 of the work from EU-Links. But essentially, what had happened, if we go to the next slide. You can see in the bottom where this fits into the overall architecture. So it's the interface and the definition for the interface between the traffic CS system and the trackside assets. And the work within the system pillar developed a number of aspects, but in particular brought in a much closer alignment with the supply industry and addressing the supply industry comments on the specifications, leading to an improved and more comprehensive version of the specifications. So those were released. They are now available for use, are in use in procurements. And as far as I understand it, at least anecdotally, the use of those specifications does result in cost reductions in terms of the cost of products coming back. So this is an example of the kind of output. I would highlight here in terms of the type of document it is. It's called a system pillar document. And I'll talk about this in the next section a bit more. It's the third element of the harmonization channels that we deal with in the system pillar. So the inputs into TSIs, the inputs into standards, but also we see as a very valid route that where there are specifications or work that can be of use in procurements that may not at the moment be topics that are mandatory or are identified as necessary to go through the European standardization process, they can still be released and can still be used by the sector through this kind of document. So it's, if you like, a very detailed specification. It's a complete specification, but it isn't, in this case, a mandatory usage. So this is, if you like, one of the material outputs of this year, and as I say, is already being used in procurements in Europe. If we go to the next slide. I just wanted to touch on a little bit about the standardization TSI input plan. So if we go to the next slide. As I just mentioned, the work of the JU, so from the innovation pillar, also linked the work in the system pillar, but also the outputs from Shift to Rail, is obviously demonstrating that a solution works, a product works, we can implement. But what is important, at least for certain areas, is that we look to address how these are implemented at European level. So the aim of the work here within the system pillar is, through the standardization and TSI input plan, to collate in a complete and transparent manner all of the outputs of the work of the joint undertaking in one overall document, so that it can be seen from the sector, but also from the European side, from the agency, from the Commission, what the outputs of the joint undertaking are in terms of expected inputs into the specifications, into standards, or into system pillar documents. So I think this is important, both because it is an important output of the work of the JU, not just to demonstrate, but also for at least those areas which this applies to, the link into European harmonization. But it also kind of coordinates the process at European level. So we have a process for TSIs where there is a mandate from the Commission to the agency that is then discussed and agreed with the sector. So the content of the standardization and TSI input plan will be a major part of the drafting of that mandate. Similarly, for the standardization process, there will be a request from the commissions of the standardization bodies, at least for the application of mandatory standards. And again, the aim here is that the information in the standardization TSI input plan is a major input to the Commission in the drafting of that work. So again, what we are aiming to do is link the output of the work from the joint undertaking into the European level processes, either at standardization or specification level. If we go to the next slide. Yeah, I mean, essentially this summarizes what I've just said, so we can go to the next slide. This essentially sets out the process. So this process was agreed in a document EURL on harmonization, which was approved at the beginning of the year. So at the moment, we're in the top box, the creation of the first version of the standardization and TSI input plan. And then there is an important second step. So in particular, in relation to, for example, the outputs into the technical specifications for interoperability. What we're aiming to do, as I said now 3 or 4 times, is to bridge this gap between the outputs of the R&I work into the specification work. And what we have seen, and based on the return of experience, there is significant value in engaging the agency early on in this process. So the agency is part of the System Pillar Core Group. It is part of the System Pillar Steering Group. It is kind of deeply involved in the ongoing work, but also then to link the outputs of the work with, on the TSI side, the ERA expectations. So there will be a process through the outputs that we check the quality of those outputs, check it with the agency, make sure that the feedback both ways is correct, with the aim of not having a black box process up to the end of the release of the specifications, then into the ERA process, and then there's a lot of time spent addressing issues which perhaps would have been better addressed earlier on in the process. So the aim is to better integrate these 2 areas, and that's an important second step once the standardization TSI input plan is defined and once we start producing the outputs. If we go to the next slide. Yeah, so this is just to highlight on the production of the standardization TSI input plan. So we are now at the process, in the process of finalizing the first draft, and that draft will be issued for consultation and review by the sector before Christmas is the aim, with a view to approving at the February System Pillar Steering Group, the March System Pillar Steering Group. So there will be a reasonable period of consultation with you in the sector on the context of on the content of the document, with a view to, as I say, having a comprehensive and high quality output to, in the end, have a clear view for everyone about what is coming up in terms of specifications, standards, and system pillar documents from the work of the JU overall. We go to the next section. So I just wanted to finish up by summarizing a few of the elements to ensure the success of the work of the system pillar. So first of all, we don't harmonize for harmonization's sake. We look to see what makes sense to harmonize at European level, starting at the operational level, but down to the architecture and specification level. And we define the principles and the framework for thinking about that in a formalized way. Secondly, I think, and this is really an essential part of the work of the system pillar, there is a constant and close coordination between the sector and the suppliers. We try and avoid the situation that we have seen in the past, where there are kind of slightly separate processes in place, perhaps in one sense railway driven, in another supplier driven, and in the end both the railways and the suppliers need to come together to agree on the approach here, and that's integrated into the work of the system pillar. We don't develop everything from scratch. If there is work from existing initiatives, if there is work from from Shift to Rail, if there is ongoing work in the innovation pillar, all of that is integrated. But you know, the bridging elements, any missing elements, we look to cover, at least on the CCS side, within the system pillar. And then a very important final area is on the commitment from the sector overall. In the end, the system pillar was set up at a request from the sector, and we depend on the resource that's been put forward by the sector. So we have, I would say, a reasonable level of commitment, but it's important that that is maintained and even enhanced in the coming years. And with that, I'll finish the presentation. I know there's another slide, but I think we can stop for now, especially given the time.
Thank you very much, Ian. I think, well, the system pillar is a novelty for Europe's rail. So we can already show after 1 year of activities that there are results and there is much more to come. And obviously, I also would like to emphasize the fact that this is not done for us. So this is done for the sector. So it's important that you are actively participating because you can actually benefit out of it. You can see that we have put in the hands of the sector the possibility to define how the future will look like. And all of these will also be accompanied, of course, by the needed research activities where, as I mentioned, where there also to support the risk that you are facing when you are innovating. So I will hijack a bit the next presentation. So I will also hijack the laptop directly. So we will not go into the presentation on the alignment between flagship projects. This will be distributed afterwards, as you can see. Largely has been already well described by the senior program manager, and as well with the system pillar, all the different alignments that we need to have. Here you can just see a first picture of the alignment that already took place or are happening at the moment. I can tell you that this is not sufficient. So it's a good start, but we need to do it better going forward. So in 2024, we certainly needed to ensure that there are concrete elements of cooperations between the flagship projects. And again, it's not something that Brussels wants, but it's something that we see needed for the successful output also of the flagship project themselves, because there are several dependencies and several input-output that needs to be coordinated. Obviously, this is a difficult exercise. It's a complex exercise. It's already very complex to manage a big flagship project, but I think it's something we need to do it. Also, we have some lessons learned in 2023, so we will also use those lessons learned to better define what are those needed interaction, and also add these in the grant agreement through an amendment, so that it's clear for all the partners. So without further ado, we can then, we have recuperated some time, and Catherine, as a Chief Stakeholder Relation and Dissemination Officer, together with Zanda as a Communication and Finance Officer of the joint undertaking, will present us in 20 minutes or so the communication and dissemination activities, and especially how we collaborate together with the project to ensure a successful output and visibility of our work.
Thank you, Giorgio, for this introduction. So I'm Catherine, for those who might not know me yet. And indeed, communication activities are always the last point on the agenda, but as Giorgio is saying very rightly, probably not underestimated activity, or to be underestimated, because we do carry to the outside world what is being done in the projects and in the system pillar in all our forums. So indeed, I want to thank all of you, because I know that you value what we do and you contribute with us a lot. We've seen the ramp up of the activities in communication, in particular with relation to the collaboration with the EU rail projects. Of course, traditionally with Shift to Rail, it was a little bit more difficult to have individual contacts with the projects, with having over 100 projects. Contacts to be managed, but now that we have more streamlined project areas, dedicated areas, and project coordinators, work package leaders for communication, project managers, and of course our program managers and SPMs, we do make a good team, and I think the communication is flowing much better than before. So thank you for this. And then I will leave the floor for summarizing the activities of 23 to Zanda, whom you know as well, is working with me in the team. I want to say we also have the contribution of Eleni, who most of you know as well. And for the moment, the help of an interim staff and a trainer. So Zander, if you want to take the floor for summarizing 23 activities, and I will talk to you about what we'll do next year afterwards.
Thanks a lot, Catherine, and hello, everyone. As mentioned, I'm Zanda, and I'm the Communication and Finance Officer here at Europe's Rail, working closely with Catherine, of course, and also closely with the communication officers of the founding members, and of course, as well of the communication work package leaders of all the projects. As Catherine mentioned, I will briefly talk about the 2023 activities, and then Catherine will introduce you to the work program for 2024. I must say it has been quite a busy year in 2023, a lot of communication and dissemination activities ongoing, finalized and completed. We have worked quite a bit on dissemination, on several campaigns as well. We have launched discussions on the improvement of the website. We've been working on several publications and of course as well expanding on media relations, maintaining good relations with the journalists, and also participating to key events taking place all across Europe and also beyond. Maybe just to briefly mention for dissemination activities, this has been a very important year for us because we have really established good relations with the different flagship projects as well as the Call 2022 projects. We've been running regular meetings with the different projects to make sure that we align on the communication and dissemination activities. We have set up a dedicated Teams environment to make sure that the information exchange is smooth and transparent, and we're always available to communicate the different news coming from the projects. We've also been helping them with the communication and dissemination strategy. So we have been reviewing them. We have been providing feedback and comments to make sure that everyone is aligned and all the good results done by the projects really get communicated to the different stakeholder groups. We've also, of course, haven't forgotten about the Shift to Rail projects because several of them were closing this year. So we have been promoting their demo activities. We have been very active as well in promoting their final events, final conferences, and the final outputs coming from these projects. And we've also started a discussion on the concept of the Shift to Rail legacy to make sure that all the good work that has been done, that it's not forgotten and that it is there on our channels and that it's readily available for all the stakeholders. But I believe Catherine will speak about it a bit more in detail in her presentation. In terms of campaigns, we've been doing a very nice campaign on the Europe skills. So we have been interviewing, filming our founding members, different stakeholders, staff, partners, and releasing each month a really nice video series to really encourage young people to build their careers in rail. We've been really promoting what are the skills needed to be able to work in rail, what are the skills missing, and really to promote upskilling of the new workforce. We've also been running article series on the flagship projects, really to give you an in-depth overview of what all the projects are doing, really to understand what is the timeline for their demonstrations, the communication activities as well, so that everybody has a good overview of what are the main achievements and what are the results that we can expect. In terms of website, we have developed a new section as well for the Europe's Rail projects to make sure that everything is in one place and readily available. And we have also started discussions on the analysis and on the revamping of the website. The major work will take place next year, so Catherine will speak more about this. But indeed, we have already launched a discussion and we are trying to see how to best approach it to make sure that we have a new modern looking website for mid next year. There are also several publications that we have done this year. So we've done the annual activity report, and another major report was the high-speed rail study that we did together with CER, All Rail, and Unife. I will talk a bit more briefly about an event that we did to launch this report later in my presentation. As mentioned, we've also been maintaining good relations with the media, with the journalists. We've been promoting the Shift to Rail legacy as well in the International Railway Journal. We've had an in-depth feature as well in the B2B magazine, and then of course several ad hoc requests from the journalists come to us almost on a weekly basis, I would say. If you go to the next slide, Liviana. Thank you very much. And this is basically just an overview of the major events that we have done in 2023. As I just mentioned, we launched a high-speed rail study, and then on the 23rd of January, we organized a very successful press event, I would say, to launch this specific study. It was well attended, gathered a lot of interest, gathered a lot of good feedback, and we also had the participation of a member of a parliament. So really a successful event, I would say, in terms of communication activities. We also participated this year to the UIC High-Speed Rail Summit back in March, which was taking place in Marrakesh. This was the first time for Europe's Rail participating to this particular high-speed event, and also the first time, I would say, really going more globally and not just on a European level. And this was again also the opportunity to really present this high-speed rail study to the broader audience, because we didn't only have a stand, an exhibition stand where you could come and meet us, but we were also speaking in 2 different sessions. So that was a great opportunity indeed to branch out, to meet new stakeholders, and to speak to new players in rail. We were also present at CIFR, of course. We had a little stand there, and as well we did a masterclass on energy efficiency in the rail sector. And then another new event for us was the UITP Public Transport Summit back in June. We had a 36 square meter stand. We were near several founding members, and it was very nice to meet everyone and to discuss as well on good approaches for communication and dissemination. It was also an opportunity for us to present again some of the results from Shift to Rail program. So for instance, we bought 4 different demos specifically related to public and urban transport to this event. So it was a really good platform to really disseminate this information. We were also part of several panel spotlight sessions, and there was also a final event of the project. So I think it was really a multiplier effect for everyone, because we were also really able to promote the different projects during this event. And of course, again, enhanced stakeholder relations. If we could go to the next slide, please. Maybe now a bit more recent events. So back in September, we organized the Space for Innovation in Rail event. This was done under the presidency of the Spanish presidency of the Council of the European Union. We did it in collaboration with ERA, EUSPA, and DG Move, and had a really, really good collaboration with our Spanish colleagues. So thanks a lot for everyone who was involved. We think it was a major success. We had a full room of participants and many watching us online. It really was an opportunity to discuss the introduction of the satellite solutions into the railway domain. We received very good feedback in our feedback survey as well. I would say it was also very interesting to go to the different site visits as well as promote the work we're doing again to different audiences, to stakeholders from the space domain. Again, more recently, we have organized the Info Day 2023. This took place on the 4th of October, and this was really to promote the Call 2023 topics. This year, we were trying out something new, I would say, because we're always thinking of how to reach out to new stakeholders, how to reach to different new publics and people all across Europe. So we decided we are going to launch this B2Match platform, which is really a matchmaking platform available for everyone to go in there, to network, to find like-minded experts, companies and so on, to exchange ideas and potentially build relations and then apply together for the call. I would say it's quite successful. We have received a lot of interest. We have a lot of registrations on this platform, so we are hoping that this will bring good results, of course, for the applications. Another point maybe to mention, we were present at the European Startup Prize for Mobility on the 26th of October. So this is an initiative that we have been supporting now for many years. And as you may know, it is hosted and supported as well by the chair of the Transport Committee of the European Parliament, Ms. Karima Delli. So we're always happy to be there, and again to enhance our relations with the Parliament. We participated in a high-level roundtable, and we also awarded a special prize on digital and green rail mobility to a startup called Rail with AI. We are now thinking as well about further relations and how to further support this startup with their good ideas. And then very recently, just last week, colleagues were at Rail Live, again, an opportunity to discuss with the Spanish colleagues under the Spanish presidency, and good participation to 4 or 5 different sessions. So again, great opportunity for us to promote the results. If you go to the next slide. So this is just a little summary of activities that we have launched in 2023, but that will have an impact on 2024. But Catherine will talk more about it. I will just briefly mention that we have started the discussions on InnoTrans. Everything is well under preparation. You may know that we will have a joint stand with ERA and DG Move, and it's an ongoing discussion, and more information is coming in the new year. To mention, we also have launched discussions on the participation to TRA 2024, so it will be a joint stand with Clean Hydrogen, Clean Aviation, and CESAR 3 joint undertaking. So really having a joint Transport for Europe stand, showing the synergies between the different JUs and showing how we work together for the benefit of the European citizens. I mentioned the website revamp, and there will be interesting activities coming as well for dissemination of the project results and for our R&I inputs. But I let Catherine speak more about it. Thank you very much.
Thank you, Zanda, for this extensive summary of 23, which was indeed very, very busy. I think we can safely say that 24 will be equally busy, if not more. Of course, as it is the year of InnoTrans, TRA, major events where we will be very prominent. So, of course, the objectives of the communication at Europe's Rail is to support the objective of the program. So we're really working and aligning on promoting not only the results of the innovation that we produce, but also ensuring that the mission and that the corporate image of the JU is brought out to a wide range of stakeholders. We do extend our stakeholders community with a number of activities that we are planning for 24. So of course, we will be raising awareness, as I said, about the JU amongst our known key stakeholders, but also expanding, as Giorgio mentioned previously, to new stakeholders. Yes, thank you for going to the next slide. We will also, of course, continue to support and promote the recognition of the JU's result at global level and promote stakeholder engagement in new forums. And you will see, I will explain a little bit later. We also continue to promote the JU within the EU institutional arena. And we lead a coherent dissemination strategy with the state of development of our projects. So we have the Shift to Rail Legacy and, of course, the new Europe's Rail projects. We proactively publish communication material at corporate level and from projects. And we, as Zanda said, will continue to expand the network of press and media contacts. I have to say that we are now in a very good position of being a trustful source of information for a number of trade media and journalists who contact us on many occasions to validate information or to have information even on policy. So it's very nice to see that we have established a trustful relationship with important journalists. Of course, we will also start work on the new website, and this is listed in the objectives because it truly is an objective, is to make this website be more user-friendly and more adapted to nowadays ways of searching for information. We want to bring you more to the website. It's been a process that has taken a lot of time because you will know that website revamping is very costly. It is extremely costly and takes a lot of different steps to make sure that you're doing something which has sense. So for this specifically, we will be having a first step, which is a website analysis. You will be, as our stakeholders, contacted on a number of issues that we would like to share with you to make sure that what will be done will be really value for money and will attract more public to our website. On the dissemination, as I said, we will continue to disseminate the results of projects and activities, focusing on the innovative solutions developed under Shift to Rail and the future solutions coming from Europe's rail. Our dissemination channels are traditionally the website. We issue press releases. We mention, of course, the state of development of all our projects and deliverables in our newsletters. I hope that all the stakeholders who are maybe new to our community are informed that we have a newsletter that you can register to. It's on our website. Please do so. Also, for information, if you need to contact the communication team, we have a dedicated communication email mailbox. And I think maybe, Eleni, you could put this in the chat to make sure that everyone knows that they can contact us for any questions. We do regular mail shots. We do presentations at internal and external stakeholders events. So we are present, and I'm trying in my stakeholders relations capacity to identify the best areas and the best forums into which speak about Europe's rail. So in collaboration with Giorgio, we work really at trying to optimize our resources to make sure we are in the key areas, key forums that are important for supporting Europe's rail. We also, of course, are in touch with the media, and we are very proactive on social media, as you know. Those who follow us on LinkedIn and Twitter encourage us a lot, and we are very happy to see that we are retweeted, reposted also by the institutions. So we have DG Move support, we have DG RTD support, and we have all of your support. So please continue to repost, to read, and give us feedback if you see anything that you'd like to see different and if you'd like to contribute on different topics. Of course, this is happening also when we have the meetings with your communication corporate officers, and we will have one meeting in particular in Q1. We will invite them to join us in Brussels and actually have a in-presence meeting with all topics related to 24, in particular with Inotrans. So I will speed up a little bit. I mentioned stakeholders relations. In the institutional arena, we are very present, and we ensure that we have links with the European Parliament, the committee, the Transport Committee, notably through our support for the European Startup Prize. We have a particular attention, of course, to the rotating presidencies, and for starting in January, of course, the Belgian presidency. We have a prominent event that will actually be an official event from the presidency on the Freight Day meeting on the 2nd of April. I will speak about this in a minute. Key multipliers, I won't list everyone, but it's very important to know that you are also our ambassadors. Staff of the JU is the ambassador also of the program, so we count on you to continue speaking about what you do and your involvement, and ensuring that the community knows and beyond that we are working together. Concretely, for activities in 2024, we will be continuing to do editorial and publications work. So we will publish, of course, the annual activity report 2023. We have a number of website articles promoting results coming from Shift to Rail and Eurail projects. We're planning to issue a new corporate video, and we will continue our campaigns on social media. For dissemination, we will work towards InnoTrans in delivering the digital and interactive third edition of the Catalogue of Solutions. And this will, of course, be the conclusion of the cycle of Shift to Rails legacy. And on this, you will be contacted as well to help us in finalizing this product. But the Shift to Rail legacy will also be shaped in other communication products, which we are at the moment testing and validating, and will be, with the help of our contractor, issuing communication packages that will be dedicated to some clusters for Shift to Rails legacy. We are trying to optimize our work, and I want to mention this on the Microsoft Teams environment, because this is really an environment, a very organic environment that is in development, that the Commission is really pushing more and more to work on. I think a shift is happening at the moment towards Microsoft Teams, and it's very handy once you are in it and you practice it. So we have working forums, we have dedicated areas to libraries to deposit documents. We can work in shared environments on Teams. You all know what Teams can provide. And so I want to just really, re-emphasize the importance of making sure that you can join us on these platforms. And we are, of course, with all our groups, communication groups in the projects, working on this actively, and it's happening. So it's very good. Website I've mentioned already. And then I will just briefly go through the events, because I see time is passing. So for next year, we will start with the Call 2024 Info Day in January. And we will then be present afterwards in April at the Connecting Europe Days. I mentioned the Belgian presidency. We will have a dedicated DAC presentation and demonstration at the Schaerbeek station, at the train, the Schaerbeek station, and the dedicated event at the train museum in Schaerbeek. And this will be the official opening of the Freight Day of the presidency on 2nd of April. The minister, Mr. Gilles Genet, Minister of Transport in Belgium, will be present, and potentially also other ministers at our event. And we will then take the minister and delegations on a tram 92 through the Egmont Palace, where the rest of the Freight event will be taking place. So we're very happy to be part officially of the Freight Belgian Presidency Day. We will then be at TRA in Dublin with a lot of demonstrators, and Zanda's already mentioned that for the first time we're teaming up with other JUs to have a common stand next to the European Commission. Then we will be participating for the first time most substantially in the ITF, International Transport Forum Summit in Leipzig. We're currently working towards the agenda together with the ITF stakeholder group, and I'm happy to see that we've been involved more with the ITF altogether. Of course, InnoTrans with a series of demonstrators. We'll have a joint stand, you all know now, with the European Commission and DG and the ERA. And then we will be sponsoring certainly again the European Startup Prize if this prize continues in October. We're intending to participate together with DG Move if the conference is confirmed to the UN Climate Conference. This is of course in support of our policy, which is of course to align with the smart mobility strategy, one pillar of the Green Deal, and we want to be more present there. Advertising for our work as one of our topic of work is dedicated to this area. And we will be working towards a presence in the Rail Transport Day of the UN Climate Change Conference in potentially November if it's confirmed. We'll have also, of course, the General Assembly of the JU, and we are planning to start organizing an event with other joint undertakings, raise awareness on the benefits of such partnerships at the Parliament. Of course, this is the time where we will be starting very early, but we will be starting to look at the renewal of the programs, and it will be important that we have full support from the European Parliament. Therefore, we want to, as we did in 2017, make ourselves present to them, but as a joint event of the joint undertakings. So it's in the planning for the moment. I'm not sure if we will really achieve it for the end of December, depending on the nomination of the committees in the Parliament and following the elections. And I think it is sufficient information from communication. I'll give the floor to Giorgio for the concluding remarks, unless you have specific questions.
Thank you very much, Catherine and Zanda. I think we have successfully closed more or less on time. We have to cut a few activities, but you can see that well, even doing 2 alpha days of General Assembly is not enough for all the activities that we are doing. There is much more to say, much more to discuss together with all of you. I think there will be plenty of other forums to do that. So let's continue to collaborate together, because only by doing this we can actually achieve all what you have heard today and more. Again, it's an opportunity you have seen for all of you involved in the Europe Straight program to be part of this definition of what the future will look like. And I really believe that if we are all in it, all for this, actually this future will be bright for rail. For sure, we have the support of the European Union, and this is also important. You have seen yesterday in the General Assembly, and with all the work that we're doing together with you to communicate and also to convince the other decision maker that rail is the sustainable transport model for the future. I think we can really make it happen. So with this, I will simply conclude the General Assembly of 2023, wishing you a successful 2024. All the best. Well, it's a little bit soon, but all the best wishes for the winter holidays. And for those of you who are here in the room, we will be now moving for a photo section.
No, we're staying here.
We're staying here.
We're staying
Okay.
here.
So we're staying here. And we will do a little working photo session. Thank you very much, and see you soon, and keep up the good work.